welcome everyone to the Regional Science Consortium's 16th Annual Research Symposium. I'm Jeanette Schnars, the Executive Director of the Regional Science Consortium. I'd like to thank everyone for tuning in today. This has been a unique symposium, being all virtual and live streamed, however, very successful with the number of audience members that were able to tune in and listen to so many talks. So thank you so much. And I'd also like to pass along a thank you to our judges that have also been tuning in and completing the judging forms. It's very much appreciated. Thank you so much. We're excited to start our third day of the symposium presentations. We had 2 full days of talks with great presentations by our faculty, researchers, and the students. The students have done an excellent job this year, so congratulations to all of you. Last evening, we also had our guest presenters, Brian Gula and John Laskos, talking about the natural resources at Presque Isle State Park, and even giving a glimpse of what to look for during the fall and winter months out at Presque Isle. So be sure to go explore and check out the park during the upcoming months. If you missed any of the talks, please visit our YouTube channel at www.regscitv.com. They will all be archived on there, and anything live streamed over the last 3 days you'll be able to find and view for the first time, or maybe even view again if you wanted to review some of the information that was presented. I'm excited to listen to today's talks. During our first session, we'll hear about the investigations associated with forensic sciences, and then during our second session today, we'll hear about the Badlands, deglaciation, green roofs, acid rain, owls, and the change in forests in Chautauqua County. So we still have a full day today of information and talks and presentations. This afternoon, after lunch, we'll conclude this year's symposium and have the student award presentations. So please be sure to tune in at 1 o'clock. I'd like to introduce Jennifer Salem from the RSC, and she'll be chairing today's first session.
Hello and welcome everyone. Thank you for tuning in to day 3, our last day of the Regional Science Consortium Symposium. As Jeanette mentioned, I'm Jen Salem. I work for the Regional Science Consortium as the horticulture specialist. And we have a full day. We have our first speaker on deck. And so I'm going to get right into it and introduce Leslie Fitzpatrick from Mercyhurst University. She will be presenting application of stable oxygen isotopes to aid in a refinement of origin for an unidentified individual. So take it away, Leslie. Thank you.
Thank you so much. Thank you for that kind introduction. So as Jennifer said, my name is Leslie Fitzpatrick. I am an assistant professor at Mercyhurst University, and I wanted to share with you today a little bit of the work we're doing at Mercyhurst to help provide identities to individuals of unknown identity. So let's see here. Awesome. All right, so to give you an overview of this presentation, we will be going over basic identification methods. So bioprofile, DNA, and stable isotopes. Then we'll turn our knowledge to the Montour County case, where I'll give you a little bit of a background, the stable oxygen isotope results for that, and future directions for that case and others like it. So you are presented with an individual of unknown identity. How do you handle this from a forensic standpoint? First thing we can do is what's called the forensic anthropological analysis. Through this, we're going to look at a variety of different things, including taphonomy, which is basically what happens to the remains after their deposition. So were they buried? Were they on the surface? Were animals involved? Maybe water. Maybe they were inside. What happens to the remains after death? Pathology. So this can include anything such as natural variation or disease processes that may affect bone. Trauma. Trauma can be things, like a broken bone or maybe a puncture wound. We're looking at skeletal trauma there, which may help us to determine what may have happened at or around the time of death, or it may be a mark with antemortem trauma of something that happened prior that's healing, such as a broken rib. And bioprofile. Bioprofile is based on extremely scientifically rigorous methods of estimation of an individual's age, sex, stature, and ancestry. So with stature, that's like their height. Ancestry is what most people would commonly call race. So we've gone through all that. We've done our forensic anthropological analysis, but we still don't know who this individual is. We passed that information along to law enforcement. They don't have a probable individual. What else can we do? We can turn to DNA analysis. Deoxyribonucleic acid profiling was actually started around 1981 for use in forensic cases, and it was officially patented in 1983 by Jeffrey Glassberg of Rockefeller University. Glassberg and colleagues actually were able to use this in a case between 1986 and 1987 to actually secure a conviction in a forensic case in Leicestershire, England. So we think about DNA as having been around for so long, but honestly, it hasn't been around that long. Approximately 0.1% of DNA is different between humans. In fact, as far as DNA goes, 50% of our DNA is the same as a banana. So DNA isn't, the end all to be all, but that 0.1% is actually really important. There's an exception to this though, with monozygotic twins. So if you have a twin who is fertilized by the same egg and the same sperm, which I'm hoping you can see my cursor here, same egg and same sperm, then they're going to have identical DNA because they were basically made of the same parts, essentially. So that's our exception. But for the rest of us, if you're not a monozygotic twin, then there's going to be about 0.1% DNA difference among humans. So what we're looking at with DNA analysis is we're looking to identify highly variable repetitive sequences. These are known as variable number tandem repeats, or VNTRs. These guys are going to repeat in different numbers within different people's genomes, anywhere from base pairs of 1 to 50 base pairs, between 5 to 50 repeat sequences. And these are going to kind of give us our DNA signature. VNTRs, specifically, we're going to look at the short tandem repeat segments of those, the STRs, which you may have, if you're familiar with this, heard them called micro or mini satellites. What you're doing is you're looking for several STRs from different locations in the genome, and that's going to kind of give us our DNA profile, our DNA fingerprint. And just like our fingerprints are unique to us, our DNA STR sequences are unique to us as well. And the more of these markers we look at, so the more information we gather, the less likely it is that similarity to another individual, so to another one of those 0.1% differences, is by chance. So we want to look at a bunch of different ones to try and, hopefully, isolate us, but also, make sure that we know that we're unique, right? So what we need to do DNA analysis is we need a reference sample, and this is going to be collected from the individual. If the individual is living, it's typically taken by doing a cheek swab, which if you've ever done one of those at-home DNA tests, you've probably done this yourself, a cheek swab, and the DNA profile is extracted from that sample. For individuals who are deceased, it may be taken from bone or another form of skeletal tissue, like a tooth, or even soft tissue if soft tissue remains. Once that DNA profile is extracted from that sample, it can be compared to either previous samples that may have been taken from that individual, either, if the person has led kind of an interesting life, it may be through a criminal database, or possibly through medical specimens, such as a previous medical biopsy that, the information may still be on file somewhere, or even the cord blood banks in cases of people freezing cord blood from delivery. You also can compare it if you have an idea of who this individual may be, either through, information gleaned through the law enforcement processes or through our forensic anthropological analyses that we did earlier. We might be able to say, hey, I think you guys might be family to this deceased individual. Take samples from them, compare it to samples from the deceased individual. You may be able to help to identify that previously unidentified individual. But there's a problem with this. If we don't have an idea of who the person is through our forensic anthropological analysis and law enforcement work, we can take a DNA sample, but it's not going to do any good because you don't have a comparative sample, because you don't know where to start looking. This leads us to inheritance matching. If we don't know where to look, then we don't know how to match people up. So related individuals, your VNTRs are going to be similar. Unrelated individuals, they're going to be markedly different. But once again, if you don't know where to start looking for a comparative sample, it's basically a needle in the haystack. You can collect DNA all day long from a deceased individual, but if you don't have anything to compare it to, you don't have anything to compare it to. This leads us back to our same problem. We're left with an individual of unknown identity. Now what can we do? We can turn to stable isotope analysis to help refine that. So with stable isotope analysis, you guys might remember this from your basic high school chemistry courses here. It's your elements on the periodic table. Your mass number of an element is composed of both the protons and the neutrons. And neutrons have no charge, they're neutral, right? But they do have an itsy-bitsy bit of mass. So you can change an element's neutron level, but it keeps everything else kind of the same, your charges, so the element remains the same. But when you change that mass because of the neutrons, you're going to change how the element behaves physically and chemically. These different forms, so different numbers of neutrons, are referred to as isotopes. There are some that are radioactive that disappear like that, and there are some that are stable, such as oxygen, which we're talking about today. These are going to remain within the biosphere, within the water, within the air, within the earth, within our bodies. They're going to remain in relatively constant values so that we can detect them over a long period of time. So we're going to go for our stable ones here. We're going to note these, and I bring this up because we'll talk about it a bit later and some people get kind of confused. We're going to talk about what's called the per mil notation with the little delta. And this is actually just a comparison of relative abundance within a sample to that within a standard. And so these standards for oxygen, we're going to look at what's called Vienna Standard Mean Ocean Water, or Standard Light Arctic Precipitation. So VSMO SLAP. So it has kind of a silly sounding acronym, but these are standard amounts that we're going to compare the amount in our sample to. So it gives us an idea based on those reference samples. This per mil notation means parts per thousand. That's why there's that extra little O on that percentage for you. So how does water vary? Why is water different? So you drink water and you think to yourself, tastes like water to me. It's actually slightly different isotopically depending on where you are. So this has to do with the Rayleigh distillation processes. With Rayleigh distillation processes, we know that lighter isotopes evaporate faster than heavier ones. Makes sense, right? It's easier to throw something lighter up than it is to throw something heavier up. It's gravity, right? So looking at Rayleigh distillation processes, we're going to think about being on the coast versus being inland, right? So this is related also to meteoric water because we think about rain, it's falling, right? So the thing that's going to fall out of the rain clouds first is going to be your heavier oxygen isotopes. So light ones evaporate faster. As far as rain goes, the heavier ones fall faster. So you're going to notice a general trend. Low elevation, low latitude, warm climates, it's going to be heavier with this oxygen 18. Higher elevations, higher latitude, colder temperatures. So going up into the mountains, you're going to have relatively more oxygen 16 present in the waters there. So this leads to different drinking water in different geographic locations having varying isotopic compositions. And so we can see here up in the mountain area, it's going to be lighter because this is more negative, right? So lighter values. Where we are here in Pennsylvania, we have a little bit of a mix here. We're kind of in this yellowish greenish band, which isn't great for researchers who are colorblind like myself, but there you go. So this yellowish greenish band, so we can see there are marked differences in water in different areas within the US. So human body oxygen sources. How the heck do we keep water in our bodies? Well, we know that we get water in our bodies through drinking and then urination, right? Because that's what it is. But water stays in our body. So we can get water in our body from a variety of different ways, including the oxygen-bound and consumed foods, so the foods that we eat, respiratory pathways, so every time we breathe in, we get a little bit of oxygen incorporated into our tissues, and imbibed oxygen. Of those three, the imbibed oxygen is the most important one as far as contributing to human body water. So this includes anything you drink. And once we know what the imbibed body water oxygen is, we can correlate it to the tap water. So, but in our tissues, what are we looking at as far as forensic value? Enamel. We know that our enamel in our teeth is permanent once it's formed, which is why we have to take such good care of our teeth, right? So it's permanent once it's formed, and it has a relatively predictable eruption schedule. Some people are late bloomers, some people are early birds, but in general, there's a relatively predictable eruption schedule. We also know, barring any genetic issues, there's a relatively predictable schedule of enamel formation. And in general, we're going to summarize this as the first decade of life, which we're going to call childhood. Bone regeneration rates are slightly different. Bone regenerates for the axial skeleton, shown in green on the left-hand side there, about once every 10 years. So you don't go, 9 years, 364 days, and then boom, a new skeleton. It's going to regenerate slowly. So any isotopic signatures we see for bone tissue is basically the sum of all previous isotopic signatures over that past year. For the appendicular skeleton, we're looking at the last 20 years. So basically all your dingly bits there, that's going to be your appendicular skeleton, your last 20 years of life. So depending on what the researcher's looking for, they can decide if they want to look at the childhood, first 10 years, last 20 years of life. So we can get snapshots. And this is just involving skeletal tissue. We can do it with any other kind of tissue, such as hair or skin. So we're going to turn our focus here to Montour County, to the Montour County case from 2017. The location of death of this individual was in Montour County, highlighted here in red. The individual was anonymously dropped at a hospital. This individual had received some injuries and was unconscious. Therefore, they were not able to tell their name. They did receive care at the hospital for a few days before expiring, and their remains were eventually transferred to the Montour County coroner. And after sitting there for a while with nobody claiming the remains were sent to the forensic anthropology lab at Mercyhurst University for analysis. So of course, as we talked about before, we're going to go ahead and do our bioprofile analysis, trauma, pathology, and taphonomy here at Mercyhurst to help give an idea to law enforcement of a general profile of who this individual may have been and who they are and how they may have experienced life. So taphonomy, pathology, trauma. What was gleaned through all these scientific studies is that the individual was most probably male, was most probably Hispanic, with an estimated stature of 5'4" to 6 feet tall, and a broad age range of 38 to 62 with a narrower age range of 45 to 55. This was great. This was great information to provide law enforcement. Unfortunately, the remains were still unclaimed. So I was permitted to take samples of the central incisor from the maxilla, so crown development after about 4 to 5 years, and the first molar of the maxilla with crown development around 2.5 to 3 years of age. I did also take a bone sample of rib to see if this individual, to do a comparison to see where they spent the first part of their life versus the last decade of their life. So looking at our first maxillary molar, with it being formed between 2.5 to 3 years of age, we see that our stable oxygen isotope values were negative 3.3 per mil comparative to our reference standard. So that's going to align with this band, kind of an orange here, kind of this deeper orange band. Okay, so we can see here, not in Pennsylvania. We can also see here, I did that secondary sample just to make sure, it's always nice to have more samples, that it also was within that band. Sorry for the stuttering there, was within that band. So it kind of helps to reassure that what the data we're receiving is actually probably fairly accurate. And since I was less concerned about where they spent the last 10 years of their life and more concerned about where they were from, I only took one sample of rib just for good measure here. And we can see it bands up in kind of this yellowish area which is right about here, which is right around where Montour County is. So if we compare this with global stable oxygen isotope maps, we can see here, once again, none of the numbers have changed. We've still got up here. But if we do it to a wider picture, possible origin could be anywhere through this orange banding pattern. With the individual being of probable Hispanic ancestry, this opens up a whole new pathway for us to look for the individual's potential origin. So summarizing this, you cannot exclude Montour County as the region of residence for the final decade of life. And this is based on the bone signature of this individual, the stable oxygen isotope signature. So it is possible that they resided in Montour County or a region like Montour County as far as stable oxygen isotopes go for at least a decade prior to their expiration. You can, however, conclude that you can exclude Montour County as a region of origin, though. The stable oxygen isotope signatures of enamel do not match anything even remotely around Montour County or even anything within the state of Pennsylvania. And so what this does tell us is there's marked geographic mobility across the individual's lifespan. We know that they moved around. So future directions for this. We would like to refine the region of origin using strontium isotopic analysis. So you can see here on the left, the water map versus the strontium map for the US. So whereas this is kind of spotty, this is far more refined. This does require advanced techniques and it is quite expensive, but we're hoping to get this done at some point in the near future. Once we have an idea of this map in conjunction with this map, all this data together, combined with our bioprofile data, it would be nice to be able to send this to specified regions law enforcement to tell them, hey, we have this person, please help us find who this person may be, get with family members who may be missing someone, let's get some samples, let's do that DNA, and let's put everything together, tie it up with a nice neat bow and get this individual home. So special thanks to Dr. Dennis Dirkmatt, Department Chair in the Department of Applied Forensic Sciences, for permitting me to do this work. The faculty and students of the Department of Applied Forensic Sciences at Mercyhurst and Ridge College at Mercyhurst, and to the Tom Ridge Center for allowing me to present here today, and to all of you for watching. Thank you guys so much. And if you have any questions, please feel free to reach out to me here, or if you'd like to learn more about our work, also feel free to reach out to me. Thank you so much.
Thank you, Leslie. That was a really great presentation. So we don't have time for questions right now. We're going to move right on to our next speakers. And judges, just to let you know, this is a presentation that is eligible to be judged. It is a morphometric study on sex estimation of the pelvis on skeletal remains, a pilot study. And the two presenters are Emily Brooks and Teresa Decree. They are both graduate students. So Teresa and Emily, when you are ready, take it away.
Thank you. Our research is looking at a sex estimation study on the pelvis. So just a general overview of forensic anthropology. Forensic anthropology is the application of forensic archaeology, forensic taphonomy, and forensic osteological analysis to aid in the identification of unknown individuals. So the osteological analysis that most forensic anthropologists will conduct include information on individualizing characteristics, trauma pathology, and most importantly, the biological profile.
So what is a biological profile? Leslie did a really good job of already introducing it, but it's basically an amalgamation of components needed to attempt to determine identifying information for unknown individuals. And these components consist of sex, age, ancestry, and stature. And it's important to note that age, ancestry, and stature estimation methods are often dependent on sex. So sex estimation methods mostly rely on the pelvic girdle. which is consists of the right and left oscoxen, which are also called the annominus, which will be referred to in this presentation, are also known as your hip bones, the sacrum, and the coccyx. We tend to see differences based on sex due to procreation demands, which is childbearing, as well as sexual dimorphism, which is a general concept that males tend to be larger than females in regards to size.
With the biological profile, there's different methods in evaluating the different parts of it. So we have qualitative and quantitative methods. With our qualitative methods, these are more reliant on experience and training. Due to this, they're generally more subjective and they produce higher error rates and they're less statistically sound. Quantitative methods consist of metric data and require less experience and training, so they're generally easier to apply. They produce lower error rates and are statistically backed due to the lack of subjectivity, and they're suitable to be presented in legal and court settings. The methods that we use are subject to Daubert standards when used in court, and quantitative methods more often meet those standards.
To delve more into quantitative methods, there is a type of methodology called geometric morphometrics, also called geomorphometrics, or abbreviated as GM. They are reliant on the exact spatial locations of the landmarks previously used to take the classic anthropometric measurements and are useful for defining shape. Overall, it's the conceptualization of the shape through the collection of measurements to quantify morphology. So considering geomorphometric techniques, we wanted to implement said techniques through validation. This is how we chose the article by Decker et al. Titled Virtual Determination of Sex Metric and Non-Metric Traits of the Adult Pelvis from 3D Computed Tomography Models. This was published in the Journal of Forensic Sciences in 2011, and they utilized a sample size of 100 articulated pelvic girdles from a known sample. And through estimating sex from CT scans and 3D imaging in vivo, they created 18 measurements. And from 4 of those specific measurements, they're able to create a sex estimation equation, which led to them having 100% accuracy in assessing sex of individuals and produce a low interobserver error rate of 2.2%. So to compare these results in Fortis, they want to make sure that it can be utilized when forming the biological profile. So overall, they compared their accuracy in assessing sex to Fortis. So Fordisk is a common software used in forensic anthropology to estimate multiple aspects of the biological profile using quantitative data.
This is just an overview of the points that Decker used over here on the left, and then on the right we have the images, the CT images that were used to take the measurements. So obviously all these individuals were alive and the CT scans were of a completely articulated pelvic girdle. This led to easier measurements of the pelvic inlet due to the presence of soft tissue and the preservation of all skeletal elements. In Decker's results, he reported, like Emily had said, 100% accuracy with the following formula, utilizing the greater sciatic notch, the iliac height, the transverse pelvic outlet, and the subpubic angle. Not all of these were found, not all of these features are always preserved in a sample in bioarchaeological and forensic anthropological settings, but we'll go more into that later. So if the result from this equation was less than 0, the individual was categorized as a male, and if it was greater than 0, categorized as a female. And like Emily said, these were compared to Fordisk. Fordisk showed an 86% accuracy of categorizing each individual, as opposed to Decker's 100% accuracy.
What are the limitations of Decker for us when collecting data? So overall, we do struggle with skewed sample sizes, which we'll get into in a little bit. We discovered that at least 2 individuals are needed to employ this method. As opposed to our methodology of using a protractor. Decker takes into account soft tissue, which must be approximated on dry bones. And two of the measurements are dependent on the articulation preservation of the coccyx, which is the red portion of the sacrum highlighted on your right, which is not reliable for forensic and bioarchaeological settings. It's very rare to find it articulated and completely intact.
Additionally, 2 individuals were needed to take the measurements because the pelvic girdle had to be held in articulation when taking the measurements, and this introduced additional error due to we would have had to approximate the amount of soft tissue in between the pubis, and also just after holding for a while, it can lead to shifts in the pelvic form.
We also had to estimate tissue for the sacroiliac joint as well. So when considering the limitations of Decker, we question if there is a more reliable measurement that could be applied to dry bone to either add to Decker's pre-existing equation or replace one or more measurements to quicken the process to make data collection more effective and efficient. If such a measurement were possible, then Decker could be enhanced to be better suited for forensic anthropological and bioarchaeological research. As we stated previously, it is more realistic to encounter either a single anomaly or both right and left anomalyments rather than an entire intact pelvic girdle that Decker solely depends on. So when considering the C measurement, we want a measurement that would measure the pelvic inlet, a trait that differs between males and females in morphology. We first encountered this measurement in a 2016 dissertation by Anja Witt through the University of Pretoria, who assesses the geomorphometric points of pelvises in correlation to birth canal size, as well as in different ancestries. But this measurement does vary slightly from what we originally had in mind. So the new measurement we wanted to propose was a superior medial aspect of the pubis that extends to the apex of the auricular surface. And for the rest of this research, we decided to call it the anterior posterior pelvic displacement, also called APPD.
So the goals of using this measurement were to better understand the applicability and limitations of Decker et al. On dry bone, because just with the measurements that he was using in the article, it was kind of interesting to us that he used things that depended on the coccyx because it does not preserve as well. And we also wanted to better understand the applicability and the correlation of the newly proposed measurement, APPD. We also wanted to see if the newly proposed measurement could improve on Decker et al., combining some of the more highly correlated measurements in Decker's method to our measurement to create a new equation for forensic anthropological applications. Our hypothesis is that Decker et al. Will have a higher error rate on dry bone than it did on the CT scans, and the newly proposed measurement will have a lower error rate.
So the sample for collecting data for Decker et al. And APPD measurement came from the donated collection at Mercyhurst University. Our sample includes male and female adults ranging from the ages of 40 to 96. For Decker et al., we had a sample size of 26 with 21 males and 5 females present. Meanwhile, our sample size for APPD measurement was 32 with 22 males and 10 females. And this difference in sample size is due to the need for complete pelvic girdles versus unarticulated dominants. We do have more unarticulated dominants in our collection, so therefore our sample size is in fact larger.
So when applying the Decker et al. Method, we utilized sliding calipers, measuring tape, and protractors. The protractor was used to calculate the angles such as the subpubic angle and the greater sciatic notch. Like we said previously, 2 people would be needed to collect these measurements to have the pelvic girdle articulated. All 18 measurements were taken, if possible, based on the preservation of the bone, and were taken by both authors for inter-observer error. Data was inputted into an Excel sheet by each author to avoid any bias, and measurements were based on definitions provided in the article. The majority of the definitions just provided information about the landmarks themselves. Because they were using CT software, they just put points on those landmarks and then measured from there. They didn't give detailed instructions on how to take the measurements on dry bone. So part of our research was finding those limitations and guidelines as well for dry bone. And here's just an example of our data collection.
So for taking our measurement APBD, we utilize sliding calipers. And ideally, you want to hold one point of the sliding calipers at the most anterior point of the apex of the auricular surface to the most superior medial point of the iliopubic ramus, technically as close to the midline as possible. And for the best results, it's best to set the pelvis on its side with the medial surface facing you as depicted in the picture on the right. So each measurement was taken 3 times on a single anomaly to ensure accuracy. And each measurement was taken within a 2 millimeter range of one another. Once a single measurement was reached, for the clocks of the measurement would be input into an Excel spreadsheet, which you can see on your right. And the process would be repeated for the anomaly of the other side if the anomaly was in fact available. So you can see in the spreadsheet, we have our individual, our tool numbers, and then the measurement for the right and left off-taxa. We wanted to know the tool number in case we saw trends of measurements being outside of our 2 millimeter range to see if we can track if tools were in fact calibrated incorrectly, but from analyzing it, we didn't see such a trend, which is good. So once all our data was collected, we were able to run statistical analyses to better understand what we had. From Decker et al., we could have collected a total of 468 metric points, but we were only able to collect 359 points due to preservation. This means that we could only take around 77% of the points possible. And this is mostly due to the fact, as we said, some of the measurements solely rely on the presence of an entire coccyx, which we do not have. And it's also good to know that one of the measurements required for the equation that produces 100% accuracy is reliant on the coccyx being available. So therefore, since we did not have coccyx entirely present for the equation, that means that technically 0% of our sample could be utilized for Decker's equation. For our APPD measurement, out of a possible 64 points, we were able to take 57. So in general, it could be divided as 32 for left anomalous and 32 for right anomalous. So this resulted in us being able to take 89% of all possible points. So when relying on a single anomaly, we were able to take 100% of our sample. But it's best to keep in mind that since this is not a random sample, the statistic may not be representative of the applicability of our method. So something to keep in mind.
Just going over the inner observer error. So for Decker, he reported that there was a 2.2% inner observer with his method. In our research, when we applied his method between the two of us, the error rate was relatively low between our measurements. So it was 1.89%, which is good to show that the majority of the measurements were clear enough that we were able to apply them consistently on dry bone, where the application was applicable, that the landmarks were present. So the highest rate of error, however, was 4.3%. And this was actually for the greater sciatic notch, the angle. That angle is necessary for Decker's equation. So its variability is just based on, that angle is harder to compute on dry bone than in a software. So that correlates with higher rates of error with that equation if we were able to have all the points to begin with. And then for our measurement, we had an inner observer error of 1.25%, and then an intra observer error for our measurement of less than 1%. So our measurement showed to be fairly replicable. And just to review the results between the two. So results reveal low collinearities between the variables in Decker's method, suggesting that most included variables contribute relevant information to the diagnosis. So basically that says the majority of the variables in Decker's do in some way, whether it's a low correlation or a high correlation, connect to sex estimation, and their model does not appear to suffer from overfitting. Variables in the original method capture a very large proportion of size-free shape variation, with large variances explained in most variable combinations and a number of significant roots exceeding 4 to 5 in all multivariate combinations and methods, and size explaining a proportion of the variance only in the 30 to 40% range. So this is basically saying that the pelvises, because of the differences in sex, do represent different morphologies to accommodate birthing in females, and that just the size of the Ascoxa only explain 30 to 40% of that, so it is more dependent on the shape. In this sample, there was a decrease in accuracy inversely proportional to the number of preserved variables. So as we're missing each landmark or whatever is not preserved, every time we lose a landmark, we're losing accuracy as well. Some of the variables also displayed larger inter-observer error rates, such as the GSM, which was just went over, which could potentially affect accuracy. APPD proved to be easily and consistently measurable, frequently preserved, and a useful addition to the variables in the original method.
So in considering the limitations for our new measurement for APPD, overall, we did have a skewed sample size. For both of our sample sizes, we did have far more males than females. And it was difficult to distinguish the most mediosecure portion of the apex for some of them. This is either due to the pathology or the morphology of the Ascoxa of that particular individual. Sometimes the margin of the mediosecure portion of the apex was slightly unclear.
So just to conclude everything, to go over our results, we had low inter and intra-observer error shown in our method and in our application of Decker's method. However, pivotal measurements had higher error rates when concerned with Decker's method. APPD showed a positive correlation with sex estimation, potential for APPD to replace certain measurements in Decker et al., but a larger sample is needed to validate this statistically. Our hypothesis was that within our sample, Decker's method could not be applied due to preservation issues and a lack of soft tissue. This was proven correct. And APPD measurement had a lower inter-observer error rate than Decker et al.'s method. This is also correct.
For us, further research is needed, so we do aim to increase our sample size to ensure statistical accuracy. We are attempting to go to outside collections, so that way we can increase our sample size to 100, and we can have 50 males and 50 females. And then we're also in the process of collecting inter-observer error for our own measurement through an undergrad student going ahead and taking the measurement for multiple Ascoxae so we can see what that percentage would be.
And then with all the data that we intend to collect from an outside collection, with those additional data points, we hope to create an equation that to represent an accurate sex estimation method with the combination of the APPD measurement as well as some aspects of Decker's, and then compare those results against Fortis, which is currently the field standard for metric biological profile estimation.
We just want to take this time to thank Tom Ridge for allowing us to present, Mercyhurst University for allowing us to use the donated collection, as well as the Department of Applied Forensic Sciences. So thank you to faculty and fellow graduate students, particularly Dennis Dirkmatt and Louis Pablo. And also thank you to Nora Butterfield, who is our undergraduate right now doing our inter-observer error collection.
Thank you so much. I don't know if we have time for questions.
Okay, Emily and Teresa, we do have time for one brief question that came in. What would lead to the entire pelvis not being present?
So when we're looking at either a forensic setting or a bioarc setting, you know, there's taphonomic factors, so the environment can influence preservation of remains. So as an individual is outside for longer or wherever they are for a longer period of time, these like wind, water, soil, like all these factors influence the condition of the remains. Just like anything, the bones over time will wear down. Or you could have an issue where only one innominate is recovered. Not every skeletal element is recovered, because once that connective soft tissue decays, it is free to like the forces of gravity and everything like that, and skeletal remains can be scattered.
So just to clarify, when we do recoveries for forensic anthropology, it's really common for there to be scattered remains. So animals of any particular kind can go ahead and take skeletal elements away from the main concentration, and therefore they're not actually present when a recovery is happening. So that's also why a pelvic girdle or an oxycoxylate cannot be present, because they have been moved by animals.
Thank you for the question.
Thank you.
Okay, wonderful, thank you. Appreciate the answer to the question, and we will be moving on. Judges, this is a speed talk, so you will not need to judge this presentation. This is by Victoria Lamond and Samantha LaFrance, and it is a pilot study on 2D and 3D image distortion, a forensic anthropological approach. So Victoria and Samantha, you're on.
They're going to use my laptop as well, so just 1 second. All right, hello everybody. It's not sharing. Oh, it's not sharing. Oh, there we go. Okay, perfect. All right. Hello, everyone. Sorry about the delay there. My name is Victoria.
And I'm Sam.
And we are presenting on a pilot study on 2D and 3D image distortion. And we're taking a forensic anthropological approach. So what does that mean and why is it important? Basically, the short answer is accessibility. Access to in-person resources for forensic anthropological studies is often very difficult because of location or cost, and this has been compounded by COVID-19, as we all know. We're relying more and more on virtual learning and research, and being able to understand how these measurements can be distorted by various media can be really crucial in increasing the accessibility of these collections. And so this distortion is known, it's measurable in radiographs, and so we wanted to take a look at other media to see if we could quantify that distortion. So in order to do this, we used a Konica Minolta digital X-ray machine, a Canon Rebel T5 digital camera, a 3D scanner from Artec, and then on the low-tech side, an osteometric board and sliding calipers to take measurements of dry bone. And the bones that we used were 10 left femuri from Mercyhurst University's donated collection. How did we measure? So the 5 standard osteometric measurements of the humerus that we took were from Haas, 1994, and those are used in biological profile analysis. So the first 2 that we took with the osteometric board are maximum length and epicondylar breadth. So I'm going to hold this up if this will work. I don't know if it's going to go. I think it's just lagging. Quite lagging. So this is the maximum length, as you can imagine, from the head down to the end here. And the epicondylar breadth will be from here to here. And then the sliding calipers, we use the vertical head diameter from here to here. And the minimum and maximum diameter at the mid shaft, we use the sliding calipers right around here. And basically just roll it around until we find the maximum and the minimum. And so we used, so that was for dry bone.
We did have to slightly modify those measurements on the radiographs, which we'll go into in a minute, to account for how the 2D image can be impacted for 3D traits like diameter. So like I said, for the dry bone, we use those standard measurements, and we use those same ones for the 3D scans. For photographs and radiographs, we did multiple measurements of things like the diameter to account for how it can distort from a 2D image to a 3D image. So we did it straight and diagonal, which basically we went from here to here as the crow flies, and then sort of adjusted it. Then we also did it anterior, posterior, which is this way, and medial lateral, which is this way, just to see, because of the unique anatomy of the humerus, if there was any distortion between those images. Okay, so we compared our measurements using several different softwares. So in this image on the right, you're able to see our radiograph compared with our 3D scan compared with our photo and dry bone sample of the same individual. And basically, for the radiograph and the photographs, we used ImageJ software, which essentially just allows you to make your own scale and measure pixels within an image. And then the measurements for 3D scans were taken with the program for the Artec 3D scanner, and that's within the same program. Okay. So for our analysis, you can see here we have several different pictures of the same individual. So we can see how the measurement was distorted among different media. So we've got our maximum length of the dry bone. We took a 348 millimeter measurement for the maximum length. On our photograph of the same individual, it presented as 353 millimeters. On our radiograph, 354 millimeters. And then on our 3D scan of the same individual, the max length was 343 millimeters. So those changes are as a result of this distortion of the media that we're using to take an image of the bone. So talk a little bit about interobserver error. So our range for interobserver error in the field of forensic anthropology, it's widely accepted that 2 millimeters is okay. So if you're within 2 millimeters, then the measurement doesn't need to be checked, essentially. So 98% of our dry bone measurements were within this range. And as you could see from the previous slide, obviously not all of our measurements were within that 2 millimeter range. So of the other measurements, the photographs had the lowest rate of error, followed by the radiographs, which had a slightly higher rate of error. And then the highest rate of error was actually, surprisingly, the 3D scans. But that's actually as a result of our smaller sample. We had a smaller sample of 3D scans, so we didn't have as much of an opportunity to explore the interobserver error rates of that particular medium. So we will have to do further research there. Also, we saw higher error rates with larger measurements taken. So the max length had more opportunity for error. So we had higher error rates on the maximum length in general. Also, radiographs are known to distort images. It's called a phenomenon called parallax distortion. It's just basically how far the object is from the lens and how the lens is hitting it. Essentially, that's a known phenomenon, and it can be constant and is measurable, but each machine is different. So we're kind of exploring the radiograph machine that we have. And also, a source of interobserver error is that maximum and minimum diameters at the midshaft, as you can see on a humerus, it's 3D, so your circumference is round. So it's very difficult with a 2D medium to see, to basically measure that and measure a 3D measurement with a 2D medium. So there's a little bit more interobserver error with that particular measurement in general as well. So our results, very preliminary results, we definitely have distortion in radiographs. And it can vary with the type of X-ray
and the view that it's taken in. So as we talked about, we took several different views of the bones. We took anterior, posterior, which is front and back basically, and medial lateral, which is side to side essentially. And we also took 2 different types of measurements for the max length on our radiographs. So you can see on this graph here that the 2 lines represent the 2 different views. And we can see that the diagonal and the straight measurements of the max length are parallel. And that essentially means that the distortion is constant. So because they're parallel to each other, that's a measurable constant distortion that's happening. So that's a good thing. That means that we can figure out the level of distortion and kind of mitigate it. So basically it has the same slope and different y-intercepts. Okay. And then this graph here essentially just is showing our preliminary results for these 10 humori. Obviously these lines are not parallel, so it will take a little bit more work to figure out what kind of equation we can use in order to basically come up with an equation that will correct for the distortion that we have in these different media. So we have our different slopes down here and different y-intercepts. So we have a little bit more work to do with figuring out how these relate to each other statistically. So as I said, we've got some further research to do. So what we're going to do is add 20 humori to increase our sample size to 30 in total. And increased sample size will increase the accuracy of our statistical results, the law of large numbers. Measurements will also be compared to averages for humori based on sex and ancestry in FORDISC. So as we talked about with Emily and Teresa's presentation, FORDISC is a really important tool for forensic anthropologists to metrically assess sex and ancestry for the biological profile. So we want to be able to try and quantify the impact of these distortion error rates on the biological profile if we're measuring from a 2D medium. And we would ultimately like to create equations to correct the distortion. This ultimately, our goal is to increase accessibility because 3D scanning software is, of course, a little bit more expensive and is not widely available. And it can be hard right now, especially with COVID, to physically go and measure dry bones. So the ideal situation would be to have an equation that would allow us to take accurate or mostly accurate measurements from photographs and radiographs to do our research. So that's the end goal. We'd like to thank our partners, Colleen and Teresa and Emily for doing this research with us. And of course, Mercy Hirsch for the collection. And yeah, that's all.
Thank you, guys.
Thank you.
Okay, thank you very much for your presentation. We are going to go right into our next speed talk. And we probably will push right through to our next session and skip our break. So this is the importance of recognizing the indicators of vulture scavenging in forensic anthropology, a case study from Central Pennsylvania by Christine Kortonik and Anthony LaFranchi. And so when you two are ready, please proceed.
Thank you so much. Let's get this. Just give us 1 second, sorry.
Show all images? Nope.
All right. All right. All right. Can you guys see us? See the PowerPoint?
Yep, you're good.
Good. Okay. All right. So to start off, I'm Anthony. This is Christine. We are master's students at Mercyhurst University studying forensic and biological anthropology. We're also students along with Teresa, Emily, Victoria, and Sam, and Dr. Fitzpatrick is one of our advisors. We'd like to talk to you about the importance of recognizing the indicators of vulture scavenging in forensic anthropology. So Dr. Fitzpatrick and Teresa Emily did a very good job at summarizing forensic anthropology. So I'll give a quicker summary. As forensic anthropologists, we use our knowledge of human osteology, forensic archaeology, and forensic taphonomy to analyze human remains. We analyze all these potential factors that may have altered the human remains in the surrounding scene to allow us properly to reconstruct the death event, including skeletal trauma and our taphonomic analyses. At Mercyhurst University, we average between 80 and 100 forensic cases a year. Currently, we're at 117 this year. These cases include surface scattered human remains, burials, mass disasters, fatal fires, and forensic searches. Mostly we cover most of Pennsylvania, Western New York, and Eastern Ohio, and in recent years, we've actually been the primary forensic anthropology consultants for Puerto Rico. As you can see here in this photo, we're working on a fatal fire. This map depicts our case territory. As you can see, most of Pennsylvania, Eastern Ohio, and Western New York. All right.
So as Anthony was saying, we go to scenes, and often the scenes are outdoors where human remains are deposited on the surface. And when remains are on the surface, they can be scavenged by many different kinds of animals. And one type of scavenger is vultures. So vultures are very important to us, as all scavengers are, because they can significantly alter the context of the scene. And one of the ways in which they do that is they alter the depositional environment in which the remains are in. And previous research has shown that vultures can trample vegetation, they can leave scat behind. The picture there shows scat at a scene of where animals were scavenged by vultures. So you can see that they left scat behind there. And they have also been reported to leave a whole bunch of feathers behind at the scene as well. So vultures have also been reported to damage remains. So this image here is showing scratches that were left behind by vultures on a pig scapula. And these scratches usually wash away with cleaning, but they can also break bones. That has commonly been reported as well. And they also scatter remains when they're on the ground. So possibly one of the most significant effects that vultures have on remains is they can alter the postmortem interval. So as forensic anthropologists, we estimate the amount of time that the individual has been deceased for, and we do that based on the amount of soft tissue that's there that shows how long the person has been decomposing for. And vultures alter this by consuming soft tissue very, very quickly. So this picture here shows human remains that have been decomposing for a few days. So that's the image on the top left. And then in about just over 24 hours, they had almost completely skeletonized that individual. So if we were to go to that scene and see that, we would probably say that that person has been decomposing for much longer than they truly have.
So a bit on vulture scavenging behavior. As many know, vultures are opportunistic scavengers, so they rarely prey on live animals. There's been a few noted instances of this, but very few. Black vultures tend to prefer larger carrion, such as pig, deer, cow, and they're very consistent with that. Whereas turkey vultures were noted to be even more opportunistic, going for the smaller carrion or not their normal carrion like the black vultures. Turkey vultures have been noted to spend more time in the air searching for possible food consumption, presumably, like I said, searching for new sources of carrion. Currently, in Pennsylvania, there is no published incidence of vulture scavenging on human remains. So that leads us to our case study. We believe we have the first known case of vulture scavenging in Pennsylvania. It occurred in central Pennsylvania last year in October. The remains were located in a wooded area in central Pennsylvania, and the suspected missing individual was only missing for less than 4 months. That's really important to note moving forward. So a little bit of what we do on scene. So we start every scene with written photographic documentation. You can see here in the photo, we have Christine taking written notes of everything that we do, including the time that we got there, the information from the police, things that we found, everything. To the right of Christine is Vicky, who just presented, and retired FBI agent Mike Cochran. They're mapping the scene using a total station. We also take photographs of the scene, just everything that we see, entrances, exits of the scene, any evidence, anything that could have affected the scene. After that, we search the scene. So when we search the scene, we do it very systematically. In this picture, we have what we call a line search or a shoulder-to-shoulder search. Each individual is lined up, and as they find important pieces of evidence, they'll flag it. You can tell by the orange flags there. After our systematic searches, we'll clear the vegetation. This is also known as denuding. So we clear the vegetation in the area to help us uncover possible hidden evidence, as well as produce to show the microtopography of the scene. This is important for our taphonomic interpretation. You can see the scene's already been searched. There's flags everywhere. Following our denuding processes, we map the scene, or we document it using cartographic systems. So these maps help us with determining the location of the remains in relation to their environment, the environment surrounding the remains, and the distribution of the evidence. You can see here to the left, this is an example of one of our hand-drawn maps. There's not much left. So we isolated everything that we found important and put it in this map. And then finally, we collect the evidence. So the picture on the left is as we arrived on scene. You can see in the forefront, there is a human cranium. Everything else is leaves and branches and sticks. After we collected the evidence and did all of our scene processing, the scene is almost bare. We removed all the vegetation and anything that could have been extraneous to our interpretations. So we're very good at this and clearing, the scene exactly how it would have been during the time of deposition.
So while we were processing the scene, we just wanted to highlight some of the significant findings that are somewhat relevant to vulture scavenging. So one of the first things that really stuck out to us at the scene was the remains were almost completely skeletonized. And they were telling us that the individual that they believed it had only been missing for less than 4 months. So that was not really consistent. And the remains were also significantly scattered. And this is actually a picture of the cranium. On scene, you can see there's really not much soft tissue there. And another thing we found was about 20 feathers. So we documented the position of each one of these feathers, and then we collected it. And when we went back to the lab, we identified these feathers to be from turkey vultures. So in the lab, we took the remains back with us and we analyzed them and inventoried them. And one of the other significant things we found was we were missing a lot of different elements, which is pretty common when remains are on the surface, as Teresa and Emily were saying earlier. Just all the different factors outside can cause remains to be scattered and we can miss some stuff. But we had a lot of small elements, but we were missing a lot of larger elements. So some of the long bones of the arms and legs were missing, which was fairly odd. And we also had some damage to remains. Next one. So this image shows some damage to the medial portion of the orbits. And this has been associated with vulture scavenging in the past. This is fairly commonly broken, but we had damage to these areas and then other areas of the skull where the bones are fairly fragile.
All right, so to conclude what we found, we know that complete skeletonization usually takes about 2 years. So that would give us a post-mortem interval of 2 years, according to Dirkman et al. The advanced state of decomposition in the remains that we found in relation to the last known contact of this individual, plus the damage of the remains, the intense scattering, and the presence of feathers definitely indicates vulture scavenging. Due to the evidence of vulture scavenging, we adjusted our PMI estimate to 1 to 6 months. As we said, in most cases, if we saw a skeletonized remain scattered like that, we would determine it to be up to 2 years.
So the evidence of vulture scavenging at the scene allowed us to determine that vulture scavenging was likely present. And then that allowed us to explain that the damage on the remains was most likely due to scavenging activity, particularly probably from vultures. And then most importantly, it allowed us to adjust our PMI interval so that we had a more accurate interval, because we probably, without recognizing the evidence of vulture scavenging, would have said the individual was out there for closer to 2 months rather than between 1 to 6 months. And we also just wanted to highlight that, of course, more research should be done to better understand the effects of vulture scavenging, so we know how they affect the remains, and also to locate or identify further indicators, so in the future we can identify vulture scavenging more accurately at scenes.
All right, and these are our citations. We'd also like to thank Dr. Dennis Dirkman and Luis Cabo for supporting us, as well as the rest of our cohort and the rest of the students at Mercyhurst University. Let's see. Cool.
All right, thank you very much, guys. Great presentation. We're going to take a quick 1 to 2 minute break here before we get started with our next session.
Oh, they have a question.
Oh, you guys have a question.
Perfect.
This came through. All right. Do you have any comparison tests / evidence that can separate vulture scavenging marks from other animal or possible human?
So there is research on other marks from other scavengers, and we didn't note any of those on this, on the remains for this instance. Things like rodents leave specific marks. Things like carnivores, like foxes or raccoons and dogs or coyotes, will leave certain marks, and the same thing with bears. Actually, bears are known to not leave any marks on their remains. So we can compare the known marks from published articles to these marks of the scratches or the damaged orbits to vultures instead of anything else.
Hopefully research in the future will be able to show us more specific indicators, and we will be able to more confidently associate specific damage such as like circular defects or damage to the orbits more confidently with vultures.
All right, thank you very much. And we will take a brief 1-minute break.
Thank you, Seth, for having us.
All right, hello everyone. I'm Sarah Magdan. I'm the Education and Outreach Coordinator with the Regional Science Consortium. I'm going to move right into our next session and introduce our first speaker. So up first we have Colton Byers talking to us about sand provenance across the White River Badlands towards the Nebraska Sand Hills. Now judges, Colton is an undergraduate student and the name is Colton Byers. We'll have that in the chat for you. Go ahead, Colton.
Yeah, thanks for that great introduction. So like she said, I'll be talking about sand provenance across the White River Badlands toward the Nebraska Sandhills. And also I'll kind of talk about my last 2 years field experience and how my understanding of science and just science in general or in this field has evolved and changed while I was out there. And of course, I was not alone in this research. Many co-authors, some professors, which I was thankful for, and as well as some students to work with. All right, so getting into a brief outline of what I'm going to get into and dive into. So location and background, I'll cover some research background, some previous work, and I'll try and take you to a journey to our 2 locations, the White River Badlands and Nebraska Sandhills. Methods and results, I'll overview some sampling technique, field work. We'll talk about maturation trends because that's really key to understanding the science here. And as well as I'll talk about what we call Thor's hammer, which I have right here. And that was our analyzing tool. And then conclusion, what we saw versus what we were looking to see, some results, and moving forward. So let's talk some important introduction here. So we conducted the study to test whether the White River Badlands sediment is or was a significant component of the sand in the Nebraska Sandhills. The hypothesis to be tested is that if the White River Group sediment is a source for the western Nebraska Sandhills, then major element composition should reflect sand maturation with distance from the proposed source. Sand maturation is really key here. I underlined it. We're going to make sure we cover that later on. I don't want to feed too many words all at once here. And then as well as distance from proposed source. Those are 2 key factors that we're looking at in this study. Brief overview of some previous work. We attempted to characterize the sediment of the floodplains and terraces and dunes of the White River Badlands up here and characterize the Nebraska Sandhills down here. And we wanted to try and compare the composition of the 2 with their major elements. Unfortunately, we found variation in presence and absence of carbonates and additional variation in geochemistry within floodplain and terrace sediments. And the variance stymied our opportunity to confirm provenance. We did, however, discover a really nice trend in the Nebraska Sandhills, and that is kind of what we focused on in this study. And we also discovered methods to improve our data with this thing here. We always want high quality data, and that's kind of something that we were trying to get to. So let me go ahead and take you to our first location, the White River Badlands. So this is a dune field. This is drone video by Dr. Greg Baker, who is with us. There's a really small dot here. That's a car for scale on the road. We'll see a little closer here. And as we get closer to these dunes, what these are stabilized parabolic dunes. And so the morphology tells us what the wind was when they were last active. And so they're aligned with wind direction northwest. So wind was blowing northwest to southeast, which happens to be the dominant wind direction today. They were most recently active during the Little Ice Age, and they're approximately 60 kilometers north of the Nebraska Sandhills. And so based on wind direction, geomorphology, and the trend of, we are seeing a trend moving down towards Nebraska Sandhills. So we'll go ahead and look at the Nebraska Sandhills and see. Let's see here, I gotta move this. If that could be a proposed source. So we were just up here. Now we're gonna travel to this big sea of sand, the Nebraska Sandhills. And it is ginormous. We'll get a nice idea of scale as we move in here. So here, these are Barcan dunes rather than parabolic. You can see interdunal lakes and wetlands. We start to see some relief and topography. As we zoom in here, you'll see in the foreground some real relief here. A second, there we go. Now keep this in mind as we zoom out, just to get an idea of absolutely how crazy, how much sand is in this place. It took 2 days to drive through here and get all our samples. It is the largest dune field in North America, active during the late Pleistocene and late Holocene. And of course, at large, the source sediment is controversial. There's still research going on trying to figure out where all this sand came from. And we wanted to see if, you know, with these trends, could we see if some came from up here? So let's go ahead and go to the next slide here. So I got to go to these places, and I got to go to the field and see them with my own 2 eyes, get the sediment samples with my own 2 hands, literally. I scooped them out, put them in the bag. I learned some field techniques like labeling your samples, label again one more time. Redundancy really helps in this case. And then also, of course, keeping the field notebook. I can't tell you how many times I had to refer back to my field notebook. And always refill your car with gas and refill your water before heading to the desert. That's another thing I really learned. But most importantly, I know where all this sediment came from because I was there. And it really helped elevate my understanding and promoted my geologic understanding of this place, rather than if someone just handed me some sediment and told me to analyze the geochemistry. So that's something really important if you get anything from this. It's going out in the field really helps science, especially when you're working with geology. All right. So here's a pretty clear map with locations. So we have our sampling localities with the black dots here, the White River Badlands, and then we have the Nebraska Sandhills down here. And so we located the samples at different things, and then what we did is looked at the major element chemistry of each sample location. We'll talk about how we got it, the chemistry with this here. But first, let's try and understand maturation. And so what I mean by that, easy definition here would be like the destruction of soft grains in the sediment yielding a sediment rich with hard quartz. And quartz is SiO2, and so we're looking at the major element Si in this case. And so up here towards the proposed source, we would have much more soft grains like feldspars compared to down here where we would say over time it matures, weeding out those feldspars and soft grains, giving us much more of a rich quartz sediment. And I will note these trends here are describing previous investigators. We found wind direction to be this way here as well as here, and also systematic changes of mineralogical and textural maturity in the Nebraska Sandhills, dominant transport northwest to southeast. So it's not too far of a stretch to say we should see our results to have higher quartz here rather than here. And so what we did, we took those sediments, used some double-sided tape, and made some slides here. This is all the slides we made here, a lot of samples. And we use the LIBS Z300, we call Thor's hammer. It's a laser-induced breakdown spectroscopy. I'd be happy to explain at the end if we have time with questions. And we used a custom calibrated curve as long as a setting that we kind of adjusted to help us get more accurate results. And then we averaged 10 data points per sample with this. Here's another look here. There's our machine, some sediment, our slide we made, and of course a protective case, very expensive equipment. And here's kind of the stuff that it can show us as we shoot our samples. We can then look into the program and look specifically at the wavelength intensity. And what's that's essentially showing the intensity of this wavelength silicon. And so we see the intensity of silicon, which means concentration with our curve. So we have a much higher concentration in the Nebraska Sandhills than the White River Badlands. This is just 2 random samples that we picked just to test to get this nice figure here. And so what we did again, we took 3 Nebraska Sandhills samples. There's yellow, blue, and dark blue. It's hard to see yellow. And you can see a much higher intensity in silicon compared to the White River Badlands, much lower intensity. And so that's going along with what we're saying should look like, and that's giving me confidence that this thing is giving us a pretty good characterization of our sediment. And so what we did is we took our each map point and plotted them using an IDW map with their silica concentrations, inverse distance weighted interpolation. And so what that's good for is how our sample is spread out and using concentrations for distance, essentially. We see here we have this really big outlier, the 63. We'll look into that in a second. Let's assume that this LIBS is giving us accurate characterizations, and then that leads us to a geologic story, and that's something we could go to the field and investigate and see if maybe there is something here giving this outlier as well as these lower ones, and try and explain that. And so if that is the case, we do see some lightening and darkening going southeast as we would expect. This trend, second order trend, giving us a more basic trend. We see almost like a star shape with maturation, which kind of leads to the geologic story of different wind directionalities per season, which previous investigators have found that may be the case. And so that is interesting. Always could love to go back out to the field and investigate that. And so I looked at that outlier and I tried to reshoot it, and it was being difficult and it wouldn't let me shoot it. And that was kind of the case for some of these slides here. They were being difficult. I had to change some settings, and I was able to get a new concentration of about 30. And so that questions, how accurate is this? Is there some samples that aren't giving us the results we want? And that's something we should look into. But let's say, just for exploratory purposes, perhaps that 63 just wasn't working well with our LIBS, just exploratory, because you don't want to just pick your data. And we see a much better trend of what we would expect. And so that's something we really need to look into in the future to make sure to give us better results. And then the trend, much better north-south, what we would expect. And it's pretty interesting what we're seeing here. Again, love to go back out to the field and see if it's geologic, or sit here on the LIBS and make sure that it's working the way I'd want it to. Leading into going back out to the field, this was my last undergrad going out, but I'll always visit there again. It was an amazing place. You can see, I don't know if the camera's in front of it or not, but this is our base camp here. We camped here, 7 to 10 days. Went out to the field, did science, came back and ate a great meal. It was awesome. I don't know if you can see down here in the bottom right, the buffalo and bison come right up to your campground. It's awesome. Always an excuse to go back out. And then here's our view from the campground out in the Badlands, Sage Creek Campground, if you ever want to visit it. It's free to camp there. I would like to say thanks to all the students out there with me, helping me, the professors, especially Dr. Burkhart. He got me out there in the science, and it really elevated my my game, and I really appreciate it. And thank you guys for listening.
All right, very great presentation there, Colton. We do have a question or two for you. So our first one is, what decisions went into choosing your sampling localities within the sampling regions of the White River Badlands and the Nebraska Sandhills?
Good question. Okay, so here's our sampling locations. So what we did is we looked at the Cheyenne River terraces, a few other terraces and floodplains. Those would all be exposed and possible sand sources for the dunes here and perhaps here. In the Nebraska Sandhills specifically, you can see how it's kind of irregular, and that's following a road actually, because this is just hundreds of miles of vast sand, and so this is following the road cut. Of course, we couldn't go into this state park here, and then as well as out here, following the road outside dunes. And then we actually got chased by a storm sampling these. But yeah, restricted by boundaries of the national park and the road and access.
All right, and then the next question we have for you is, using a wider wavelength spectrum, it's more of a comment. Using a wider wavelength spectrum, you can obtain specific mineral spectrum. And then that was followed up by another comment. Use the mineral composition to search for the place of provenance. After that, we have another question. Can you tell us what geological processes likely formed the sand from parent rock materials?
Yeah, so parent rock materials, they're going to get weathered down and pushed down to these, rivers, distributaries, floodplains, where they're turned into almost like a sand as they spend years and years coming down into smaller and smaller bits. And then what they can do is then get transported through wind or some water and then some wind. It's very complex as you move. It's not as simple as just always picking up a grain with the wind and depositing. It can get picked up, put into like the Cheyenne River, transported, and then get left high and dry by a terrace and then get transported again. So the combination of those geologic processes will get you down into where it's deposited into like a dune.
All right, and then I do have another question for you. Did you examine grain size of samples to see if there was selective sorting?
We did, and so I actually have one of those slides here. You probably can't see it very well, but here's a little higher grain, this finer grain. We did do that. I believe we found the coarser grained was a higher quartz content than the finer grained. I don't know our exact results. They weren't very finite, and so I didn't report it in this study, but we did experiment with that for sure. It was really interesting. I wish I had my results up here to show you.
All right, thank you so much, Colton. We are gonna go ahead and take a brief 1-minute break before our next presentation.
Okay, thank you.
Alrighty, we're going to get started with our next speaker here. Up next we have Dr. Matthew Finkenbinder, and he's going to be talking to us about the deglaciation of the southeast margin of the Laurentide ice sheet in northeast Pennsylvania. And also, judges, this is not a student presentation, so please do not judge. Thank you. Go ahead, Matt.
All right, thanks for the introduction. And yeah, it's good to be here and talk about this project. So just some brief background. So I'm a geology professor at Wilkes University, way over in northeast Pennsylvania. But I think this talk should be relevant to folks in Northwest PA too, because both of these regions were glaciated, and so we've got lakes in both places. And the approach I'm going to talk about here can be applied really anywhere, but also to study Northwest PA lakes. So the focus of the talk is trying to understand the history of the North American or Laurentide ice sheet. And we've got lots of lakes in northeast Pennsylvania. When I moved to Wilkes a couple of years ago, being a person that studies lakes and sediments, this was really kind of this local project that really drew me in. And we began collecting sediment cores from lakes for class projects. And so this kind of really snowballed over the years, beginning in class and then moving kind of to more independent research projects with Wilkes undergraduate students. And so the focus here is trying to reconstruct the history of the advance, but also the retreat of the major ice sheet during the last ice age. Okay, so this is very collaborative. Everything I do, I think most people in science, we don't do this in vacuum. So lots of people that helped and collaborated would be folks, many of whom are in the UK. I don't know how this happened, but I made colleagues and friends across the UK. And so people like Catherine, Tim, and Alistair helped with proposal writing and contributed various data sets. And then we had a whole slew of undergraduate students at Wilkes, Cassie Papp, Angus Fortune, and Michael Delpis, and also an undergrad in the UK, April Howden, who worked on various parts of the project. Funding is always good to acknowledge, and so we got funding from Wilkes and also from NERC in the UK, which provided money for radiocarbon dates and age control of the sediment sequences. Okay, so the background here for us is what we see here on this slide is a map that shows the extent of the North American ice sheet, or the Laurentide ice sheet, during the peak of the last ice age, and that was around 21,000 years ago. So this ice sheet, which was called the Laurentide ice sheet, covered most of Canada, Greenland, and also portions of the Northeast US and the Midwest US. And we know that the timing of that kind of peak of the ice age was about 21,000 years ago, because as the glaciers began building up on land, that drew down sea level. And so what's shown on the right is a reconstruction or a synthesis of sea level records from corals. And what that shows is that as we kind of move into the ice age, from about 50,000 up to about 20,000, we get this major drawdown or decrease in sea level. The peak of the ice age, which is called the last glacial maximum, happened between 26,000 and 19,000 years ago. And we know that because that represents the period where we have overall lowest sea levels and about 130 meters lower compared to average. Because of this, we kind of have this working assumption that most major ice sheets during the last ice age would have reached their max position about 21,000 years ago or so, and then really retreated whole scale rapidly after about 20,000 years ago. And we can infer that based on this major ramp or increase in sea level after about 19,000 years ago. All right, so here's our kind of closer to home perspective. This is a map of glacial deposits in Pennsylvania. And all these different colors represent various ages and different types of superficial glacial deposits. The major take home is that portions of Northwest PA, so up here around Erie, and also this big chunk of Northeast PA were covered with the Laurentide ice sheet. The most recent ice age, which is called the Wisconsin ice advance, that's here marked by the blue colors. And so the blue colors here in Northeast PA represent the ice cover, and that kind of is mirrored over here in Northwest PA. So really the motivation or focus of my project here is to try to understand the time in which the ice advanced into Northeast Pennsylvania and then later melted and retreated back up to higher latitudes. And for reference, over here in Luzerne County is Wilkes University in the town of Wilkes-Barre. Okay, so just a brief detour into some glacial geology. So we've got a block diagram here that shows kind of the configuration or the makeup of the edge of an ice sheet. As glaciers or ice sheets advance across a landscape, they will in effect bulldoze or plow, and they'll just kind of move everything in front. And so once the ice reaches its max position, it will deposit this really poorly sorted deposit of glacial till, which is called a moraine. And so in this block diagram, this big kind of elongate hill is the terminal moraine. And we can use that to infer the ice margin position or the max extent of the ice sheet. Once the ice melts, then it begins retreating, in this case to higher latitudes. And then what can happen is water can fill low-lying basins eroded by the glaciers, and that ends up then producing a series of lakes. And over time, those lakes would then begin filling in with sediments from erosional products coming from the catchment. So in this regard, we have two methods. There's really two approaches to try to understand or quantify the age of the ice advance and retreat. We can focus on the moraines themselves, and it turns out that people will measure the 10 beryllium isotopes in moraine boulders, and that can in turn help us quantify the age of the construction of the moraine. The second method, which is the method that I use, involves collecting sediment cores from lakes and then trying to find super tiny, really minuscule pieces of wood or twigs or charcoal and sending those out for radiocarbon dates. And if we can find those materials at the very bottom of the sequence, that can help us reconstruct the age of retreat, and therefore it kind of helps us define the approximate time of that moraine and of that advance and retreat. So you are all very lucky in that there's a great place to see this that's very close to many of you in Northwest PA. And so we could see examples of this, of the last ice age in and around Erie, in particular at Erie Bluffs State Park. This is one of my favorite places to go when I'm in Erie, really just to look at the, these sediments and also maybe from some fishing if there's any steelhead. Usually I strike out on that, so I usually focus on the glacial geology. So here at the Bluffs, we've got this exposure of this last ice age sediments. And what we have here in this picture is an exposure of glacial till. Till is this bulldozed deposit that the glacier ends up just kind of piling up, and that forms a moraine. So that records the advance and retreat of the ice sheet. And then what's located on top of this here is a whole bunch of lake sediments. So as the Laurentide ice sheet retreated across Lake Erie, it would have then began filling, the Lake Erie basin filled with water, and that formed a precursor lake to Lake Erie. And so we have lake sediments accumulating on top of that till. The approach that I would take here is I would try to find pieces of organics right above that till in the basal lake sediments. And if I could find those materials, which is like a needle in a haystack, then I could in theory submit that for radiocarbon dating. And that age would help me constrain the timing of that ice advance and retreat across the landscape. Okay, so back to Northeast PA. So here we have a map that shows Northeast PA and the adjacent states. And what's being shown here are a whole bunch of different published lake sediment and also moraine records that provide kind of some insight to the age of the ice advance and retreat in Northeast PA. So most of these are lake sediment records. The circles here with the dots are a series of published lake sediment records. And then we also have a couple of these moraine records. So one is the Bud Lake moraine in New Jersey. There's also another one further to the east on Long Island and up in Martha's Vineyard in Massachusetts. Again, what we can do is we can estimate the age of the terminal moraine using 10 beryllium isotopes on moraines, or we can use radiocarbon dates in those lake sediments, in particular at the very bottom, that would reflect kind of the initial infilling of the lake with ice retreat across the landscape. Okay, so here's a figure that shows lots and lots of data. I know it's kind of scary, so I'll walk you through it. We've got age and years before present on the y-axis, so 30,000 years ago, 10,000 years ago. This is the sea level record I showed you before. The peak of the last ice age is defined by this period of very low sea levels. And again, that happens between about 26,000 and 19,000 years ago. The other data that I have here is in this panel, I have the 10 beryllium ages from those moraines. And note that there's data here from New Jersey and Martha's Vineyard, and the age of those is about 25,000 to 27,000 years. Interestingly, if we compare that to all of the radiocarbon dates on lake sediments, they plot way up here. And so this is a series of published lakes from Northeast PA and New Jersey. And you'll see that most of those ages are about 15,000 to 16,000 years ago. This is really different. This is a pretty remarkable and drastic difference here in terms of the inferred age of the advance and retreat of that ice sheet. So we're talking about upwards of a 10,000 year difference. And there's some people that have proposed ideas. Some of the ideas are that the radiocarbon method is flawed. Other people think that there's some limitations here with the 10 beryllium ages. But I think that there's some give and take. But the reality is that we have this really big age discrepancy. And so this really motivated me to kind of think about, could we add new data to this to try to understand this apparent puzzle of the time of the age of that ice sheet. Okay, so here are my questions. And the major question I want to answer today is this upper one, what is the age of the last ice age terminal moraine in Northeast PA? And then second, when did the ice melt and retreat to the north? Another question I won't talk about is, comparing the climate conditions over that period of time to the modern. That's kind of outside the scope of this talk, though. Okay, so methods-wise, what I focus on is lakes. I'm a paleoclimatologist, and I use the sedimentary record from lakes and various techniques to try to understand long-term climate change. I would argue that lakes are very good archives of ancient climate because they're low-lying basins, and so over geological time, they will infill with various sediments and organic components. And so as the climate changes, or as a glacier changes, the inputs of those sediments change, and that produces a layered archive, which we can then collect and we can sample, and we can try to reconstruct, again, past climate conditions. To do this, we use something called proxy analysis. So proxies are indirect indicators of climate change. We have no thermometers, we have no rain gauges in the past, so we have to kind of use more indirect or nuanced indicators to make those inferences. There are many, many, many proxies, but I'll focus on sedimentology, which is really the composition of the sediments, and also the amount of organic matter or the organic content in the sediments. Those two very simple approaches tell you a lot about glaciation, whether there was a glacier or no glacier in the catchment. Okay, so we're making progress. So we'll move into a brief mention here of the study lake and the study site. So we've got a map here that shows Northeast PA. For reference, here's Wilkes-Barre in this large valley right here. Just to the south of Wilkes-Barre, we cored two lakes. We've got one called Cranberry Pond and one called New Angola Lake. And also for reference, I've got the position or location of the max extent of the last ice age here, which we define with this terminal moraine. And so the terminal moraine here is located about 20 kilometers south of Wilkes-Barre and about 10 kilometers south of both of these study lakes. I think I skipped one. Oh, okay. And so there's an aerial photo there of the study lake. That's New Angola Lake. So we went here, we collected core samples in 2017 and 2018. This was really fun because we did this in class, and so the students were really excited to go out and do field work. What also made this really cool is that our university, Wilkes, actually owns this boggy property down here. So access was very easy. We had no issues, getting there and actually doing the field work. Okay, so a bit more about field work. So we collected sediment cores in March of 2017 and then in May of 2018. In both of those trips, we collected 12 meters of sediment cores. And so overall, we have about 24 meters of core samples from this lake. When we then take them and kind of fit them all together and account for overlap, that produced about a 12.3 meter section of sediments. And so that represents sediment infill after the glacier retreated back across the lake up to about the present day. Okay, so we are getting into the results. What I have shown here is a whole bunch of stuff. This is another one of those kind of big, scary figures. But what's shown is, first off, the core depth on the y-axis. So 0 is the core top. Then we have about 12 meters or so or greater down here. I've also plotted, in this case, a series of age control points. And so we've got age control points here for the core sequence coming from radiocarbon. We have 6 radiocarbon dates. And in addition, we have 2 tephra deposits. And this was really, really interesting to me. So tephra is a volcanic ash deposit. And we have what's called cryptotephra, which is tephra that you can't see. But if we can kind of isolate those using various techniques, we can collect and analyze these kind of invisible tephra grains. And so these are coming from major volcanic eruptions. The Mazama tephra is coming from Oregon, and the White River tephra is coming from Southern Alaska. And so I've got the age model and the age control points and connected by a straight line shown here in the middle. The take home is 12.3 meters of sediments. We identified 4 zones or 4 facies. Sounds good. And that's based on differences in sedimentology. So the basal unit is called LF1. And that is what I think is varved proglacial lake sediments. That's the actual ice sheet retreating back off the lake. Above that, we have this transitional sediment. And note in here, we've got a whole bunch of radiocarbon dates. And so the take home here is that our basal age is about 19,200 years. This is what those sediments look like. This is the glacial lacustrine sediment, which is very high density, high mineral, low organic content, very nice layers. That represents the time when the ice sheet is in the catchment. And the post-glacial sediment here just looks like complete dark madness, can't really see anything. In that case, it's much more organic rich. Okay, so this is my next to last slide. This is that previous figure that we looked at. It shows, again, age on the Y. We've got the sea level, we've got the moraine records, and we've got the other published lake records. The new data here is from New Angola Lake, and what it shows is, again, ice retreat by about 19.2 thousand years ago. This is substantially older than these other lake records, but still not as old as those moraine records. Okay, so very quick conclusions. We've got this 12 plus meter record from New Angola Lake. Basal age of 19.2 thousand years ago marks the time of irreversible ice retreat. Comparison with other records is actually kind of somewhere in the middle. It's about halfway between the published lake records and those moraine records. And so I'll leave it at that for interpretations, but we're kind of still in the process of really just trying to make sense of this and figure out, if there's issues with the published lake records or issues with those published moraine records. So thanks for listening, and I'll take any questions.
All right, thank you so much, Dr. Finkenweiner. That was a great presentation. We are going to move right into our next presentation here.
This is a student presentation, judges. We have two students. We have Nathan Mayetta and Skylar Savacco, who are going to present to us on insect diversity on 2 urban green roofs on the campus of Gannon University. All right, you guys can go ahead whenever you're ready.
Thank you. Yeah.
Hi, my name is Nathan Mayetta.
And I'm Skylar Sabacco, and we would like to focus on our research, which is insect diversity on the 2 green roofs of Gannon University's campus in Erie, Pennsylvania. This research was done under the direction of our advisor, Dr. Stephen Rovsky.
A little bit on green roofs. They're an innovative way to adapt the environment and have benefits such as stormwater mitigation, increased biodiversity, and have ecological benefits. There are limited studies on the insects and animals that affect them, so this is why we developed our research, the effectiveness of an urban green roof and the quantity of different species of insects based upon newer and established roofs.
Starting off, we have our established roof, which is on our building for the Center for Advanced Engineering. It is 25 years old about, but we're not entirely sure as no one knows when the roof was actually put in on the building. We have a general setup of our traps pictured here, which include 3 ground and 3 aerial traps. For each of our traps, we had 3 of each type, and we used fly paper and then stakes to put up our aerial traps. We wanted to keep it as natural as possible, so we didn't include any external unnecessary environmental factors that would deter the insects from being stuck on our traps, and we wanted to keep it as simple as possible. Going next to our newer roof, which is years old in January, we would like to keep the same setup that we used on the previous roof, as well as we measured the area that we used on the last roof and used it to measure out the same area on this roof, which eliminates the variable of using more ground and collecting more insects. We also measured the distance between the ground and the aerial traps, which are alternating on both roofs, to keep that same as well. Again, eliminating that variable of more insects on more ground. Here's the picture shown of our ground and our aerial traps using the same method of just sticking the fly trap on the ground on the sedum and the aerial trap on a stake.
From there, we developed our hypothesis and said that the established roof, in our case, the CAE building, will have a greater amount of insects as well as a more diverse population.
Starting off with our data, we would like to preface that we did have a lack of entomological advanced knowledge going on with our research. So we did reach out to several entities, but we did not hear back from them, or they were unavailable at the time to assist us in identifying these insects. So we had to generalize all of our categories. So these may be a little skewed in the following years when we do have such resources to develop and use, but for now we do have a generalization of our insects. So starting with the CAE and the Nash Library in the spring, we did see a lot of small flies on both of the roofs, and we saw more on the Nash, but we do equate that to it being a more open space of an area. So we do feel like there's more airflow in there, as the CAE is a more covered building because there are trees over it. So we did see that there are more flying insects on the Nash rather than the CAE.
And then this is the comparison between the 2 roofs. But in the fall, our hypothesis follows what we see in the fall for the CAE or our established roof. There's more of a diverse population of insects and a higher population. We do still see the small fly taking up a lot of the overall population, but we did get some newcomers such as roly-polies and some small green worms in the fall, and we're contributing this to the weather patterns here in Erie. In the early spring, it's a little bit colder than it is here in the fall, so we assume that there would be more bugs due to the fact of the weather change.
We did put some chi-square values together, but most of them were statistically insignificant, so we were not able to use those, although we still included them as our data because they are important. So going off of the CAE during the spring, which is a little bit colder of a month in Erie, Pennsylvania, as our weather tends to shift quite heavily, we still saw a majority of small flies taking up our biodiversity population, but we did have a few other insects that were prevalent as well, such as a large fly and the small fly dart, and a mosquito as well.
This is the comparison of the Nash during the spring. As you can tell, our chi-squared values are going to be a little skewed due to the fact of a small fly heavily populated. It's 51 of the 56 insects that were found, and all the other ones were just, as you can see, single. But this would then contribute to our p-value being greater than 0.05.
Comparing the spring to the fall on the CAE building, which is our established roof, we did see a little bit more biodiversity, but again, it was not enough to be statistically significant, so we still had to rule that hypothesis out in that aspect. We did also see a new type of insect into our midst of diversity, which is the roly-poly bug. We also possibly think that it's because of the fall's warm weather that we did see this insect become more prevalent, as they are a terrestrial insect. But we have not seen them in our previous data points in previous years. So we would like to point that out, that they are a new species and they are quite prevalent in this roof as well.
This is based off of the Nash during the fall. This one is the most evenly biodiverse. So in this case, our p-value would be less than 0.05. So it would be statistically significant for us. And we did see an appearance of roly-polies, like Skylar had said. And we weren't sure if we were going to see any of these types of insects due to the trays on each roof not being so deep. But we weren't sure if the roly-polies just now all of a sudden become a part of our ecosystem, or if they had always been prevalent but we hadn't picked up on them. So that's something we'd like to look forward to in the future. And we did see for this, small fly did have not as a great of an effect as it did in all of the other.
So going off of the insects that we did collect, we focused on what possible mammalian and avian species would come to follow from those insects that would be further down the food chain as food for the rest of the species. So for our first mammal, we did focus on bats, as there are quite a few different species of bats found in Erie, some including the big brown bat, little brown bat, and eastern pipistrelle. They majorly feed on our flying insects, so mosquitoes, moths, and flies. So we did see quite a number of flies, as we would feel that the bats would come and feed on these insects and utilize the green roofs as a feeding ground as well. Although we would like to note that there is a decreasing number of bats in Erie due to white nose syndrome, so we would see an influx of our flying insects possibly down the future due to these effects that this syndrome is having on the bat population. Bats normally live in forests, but they are prevalent in urban settings, mainly focusing in attics, and we have seen quite a few bats on building spaces around campus. Going on to our eastern chipmunk, they also use insects that we have collected in our study, such as crickets, grasshoppers, and even some worms. And instead of their nuts and berries that they typically use in their diet, they're just a supplemental nutrient source so that they can get more nutrients in their diet. Again, as these buildings are on the second and third roof of each building, we would like to note that the chipmunks would possibly be able to utilize these more often because they are quite well climbers, so they are able to get up onto these buildings and utilize that space just as easily as an avian species. Focusing on their habitat, they do like open deciduous forests, which some of our established roof is covered by trees, so they would be able to use those to get up there. But they also enjoy brush areas and suburban gardens, so our green roof can be considered a suburban garden in that aspect. Furthering down the road, we would like to detect more mammalian species rather than avian using bat detectors, motion sensing cameras, and live traps, as that is just the resources we have. But further down the future, we would like to also include avian species but our main focus of direction will be mammalian first.
A little bit on the avian species that we think would be a part of this ecosystem are the tree swallows, yellow-bellied flycatchers, and blue jays. So a little bit on each. Tree swallows are a migratory bird, and their diet usually consists of flies, winged ants, beetles, and some spiders. And the tree swallow's habitat is usually subarctic, which is a prime location here in Erie and our green roofs. For the yellow-bellied flycatchers, their habitat is wet northern woods, and they have flying ants, mosquitoes, spiders, caterpillars, beetles on their dinner menu, which is great because those are all insects that we had found on our green roofs. And then going to the blue jays, these birds are bred usually in deciduous forests in the southeastern part of Canada, which we are adjacent to. And not only do they eat the insects that we had found on our roofs, such as beetles, grasshoppers, and caterpillars, but they do feast on plants such as weeds, trees, and soft fruits, making the blue jays a keystone species in maintaining the biodiversity for our green roofs, because not only are they going to eat the insects that are on them, but the foliage that is also present on our green roofs.
We would like to note that we do our research outside, so we did have some environmental factors that came across during collecting our data, such as wind and rain, that did deter us from using the 3-day period that we did collect our research on. So since we are outside, we do have unexpected rainstorms, and those would knock over our aerial traps and get our ground traps as well as aerial traps wet, and they would not allow the insects to be stuck there. So unfortunately, we did have to disregard this data, although we still recorded it, as we do think it is an important aspect to balance off of going on the different weather patterns that we do see in Erie, focusing on the drastic types of weather change that we see.
There, we wanted to look at the foliage that on the different types of roofs we have. So the CAE, the primary plant on this roof, is one species of sedum, and all the sedums are going to be relatively one size and lower towards the ground. It's not as full on that roof, as you can see from our pictures in the earlier slides, as it is on the Nash, but it is also located on the second floor of the building, and this is significant because it is located in a part of campus where there's a lot of trees and shrubbery, where our mammalian species would have access to and being able to get to that roof. So the CAE, we are seeing more of a mammalian impact than avian impact because it is also closed off but lower towards the ground. Nash, on the other hand, the primary plant is still a sedum, but there are various types, and they are changing from all different sizes, short to tall. And because it is a newer roof, each section is going to have a full area covered with all these sedums. And along with the sedums up there, various plants have also joined that haven't been planted by the staff here at campus, such as pine tree saplings, maple tree saplings, and then our special case that we'd like to note, milkweed, which would then attract monarch butterflies, which would add to our habitat and something that we would like to look into further down the road. Nash, the roof is going to be located on the third floor, and it's more open. Therefore, the avian species would have more of an impact here, being it more accessible for them to fly in and eat up some of those insects that we had found on our fly traps.
So for this research to continue, we do have a few future plans set in place, such as continuing this project annually and collecting better data and more data on the types of insects and the amount of insects that we do see in the fall and the spring. We would also like to hopefully conspire with our fellow university at Mercyhurst as well as Asbury Woods to see the different effects of urbanization versus suburban green roofs. And then we would also like to still continue the mammalian and avian species that are being affected and could possibly benefit from these roofs, as well with those insects being attracted, as well as more insects being attracted to using these roofs. But we'd really like to educate other entities on why green roofs are important to the city, not only for wildlife, but also for rainwater runoff, as well as insulation in the buildings and things like that. just to focus really on why they are not only important to the wildlife, but that is our main focus since we are looking further down the road on the mammalian species and going to be collecting more data on that as well as the insects to further that.
We'd like to make some acknowledgements. So to our amazing advisor, Dr. Stephen Robsky, who really allowed us to run with this and make it our own. Like I said earlier in the presentation, there aren't very many studies done on green roofs at the moment. And so he was allowing us to do this research, and we think that this is going to be great because we are headed more towards an urbanization as a civilization, and we think that green roofs might be the next upcoming habitat that could really help out. And then myself and Skylar are on here, and Jocelyn Scott, who is a former member but actually has graduated, a part of our team. She really helped us at the beginning establish exactly what direction we wanted to go to and what we wanted our focus to be in.
We would like to note our sources that we got some of our information from and to back up further information that we found ourselves. And then at this time, we will now be taking any questions. Thank you.
All right, thank you so much, Skylar and Nathan. We do have a question for you. It says, do you have any idea how your green roof insect community diversity compares to low profile vegetation habitats not on roofs that are nearby?
Currently, we don't. We were only focusing on our roof, but again, we would like to further on more urban and suburban roofs at Asbury Woods and Mercyhurst to compare the different types of communities that these roofs are in, but we would also take into consideration the types of foliage that is around Erie, probably on Presque Isle as well, just to see how they compare to that. So that would be in our future plans as well.
All right, and then there is an additional comment, not a question, but it says that Mike Campbell from Mercyhurst would love to coordinate including Mercyhurst green roof in your research. So just throwing that out there for you guys. You might want to contact them.
Good, we will be in contact with you then.
All right, we're going to take a brief break until 11:20 for our next talk. Thank you.
Thank you.
Thank you.
Okay, we're going to go ahead with our next presentation. Up next we have Ray Marzalek, sorry if I mispronounced that, and he will be talking to us about the impact of simulated acid rain on soil-dwelling invertebrate communities. You can go ahead, Ray.
All right, so good morning. My name is Ray Marzalek, and I will be discussing the preliminary findings of the impact of acid rain on soil-dwelling arthropods. So just some background information on this. This was something that was started in 2014 by a previous Allegheny College student, where they started pulling out soil samples and leaf litter from Allegheny College's Busan Research Forest. It's a mixed forest. It's about in northwestern Pennsylvania. And the goal of it was to see how anthropogenic nitrogen affects these communities. These communities are very ecologically important. They do a lot of nutrient cycling. A lot of the members of these communities, such as the springtails, play important roles in predator-prey interactions, as well as helping manage fungus populations, all sorts of good things. But the thing is that there's very minimal research on how nitrogen actually affects these animals. Most of it is done on fungi or plants. So this is an image of the Busan Research Forest taken about last month. So like I said, it started in 2014. And what the process was there were 4 different plots. 4 of them were control, 4 of them had nitrogen addition. These plots had started this nitrogen adding process all the way back in 1993, just to see how that would affect the long-term effects of leaf litter. And so there were 2 main ways that insects were collected. One way was that leaf litter samples were taken from these plots, the other being soil cores. So within each plot, they were divided into 4 quadrants, and within each one, a soil core and a leaf litter sample would be collected. They would then be taken, put into labeled bags with the name of their sample size, the date, and they were brought back to a lab. They were dried, and then all the arthropods within them were then identified and tallied. There are also multiple ways of that the previous person analyzed this data, and we'll get into that a bit later on. So this is an example of the data entry sheet. So it has the collection date, the treatment, so whether it was control or had a nitrogen addition, the plot number, the quadrant that it was in, the sample types of a soil or leaf litter, and then it had the order of the arthropod with 2 exceptions. And so that was then later analyzed mainly through a series of comparisons between all sorts of things, whether it was between different species or different months, different samples within those months. And so this is an example of a Shannon-Weiner index in order to help determine evenness and species diversity within these plots. And so what was found is that over the 65,000 individuals counted, the vast majority were of the classes Acari, which are the mites, and Collembola, the springtails. And the reason why they are organized to class instead of order is because mites are really hard to identify to an order. And so I've had to continue that as we kept going along. The previous researcher also identified millipedes and centipedes to their class, but I have since gone back and redone all of those. So we've come up with 17 different orders and 2 classes amongst these, and we're also identifying fly and beetle larvae, because just to see whether typically they have soil-dwelling larvae, and we're seeing if nitrogen, or the lack thereof, affects how that communities work over time. So the main results are these. So a lot of the comparisons were done from the 2 largest samples that have been completely done now, which were July 2014 and November 2014. So in July, we saw a large number of beetles compared to, and the control compared to the nitrogen, where the control was about 10% beetles, and the nitrogen was only about 1.5%. November, on the other hand, saw a lot more fly larvae than any other sample type or date based on if it was control and a soil core. And generally, in every month except November, the leaf litter had more species, had a larger abundance, with this one exception being November and the fly larvae. In terms of abundance, August actually had the highest amount, had the largest amount of biomass of leaf litter, and within leaf litter, November had the least. But on the flip side, November had the highest biomass in the soil cores, where July had the lowest. There was also a significant difference between the average diversity between July and August. And then some other common things. So it's just a picture of a lot of bugs under a microscope. Other than those springtails and the mites, some other main players were the beetles, the pseudoscorpions, and spiders. So what's left for me to do? So for starters, I need to finish the identification, because while the previous study had from July to November, there was also samples taken from April to June of 2015, and those were left unfinished. So I'm finishing all those, as well as going back and reordering the centipedes from the previous study. So that way we can look over this data over essentially a year-long time frame. I also need to determine how exactly I want to analyze this, because there are many different ways to analyze all of these, all this data, because there's months, there's soil types, there's soil quadrants, there's just a lot going on, and so I'm gonna say overwhelming amount of things that could be done. But the goal of that is just to look for patterns, if there even are any, because I mean, there's a very good chance that there's no significant differences between these control plots and these nitrogen added plots. And I guess, are there any questions, comments, concerns, thoughts on life?
Thank you very much, Ray. I'm going to give a couple seconds to see if any questions come through the chat. All right, we don't have any questions coming through. Thank you so much for your presentation. We're going to take a brief break until 11:30 for our next presentation.
Thank you.
All right, welcome back, everyone. We're going to get started with our next presentation. This is going to be a summer 2020 survey of owls of Erie County, and it'll be Mike Campbell talking to us. Whenever you're ready, Mike.
All right, thank you. I suffered some insomnia last summer and remedied it by going bird watching when I woke up in the middle of the night. And after a couple of times out, decided, hey, you know, this seems like data collection. So I started keeping careful records of what I was seeing early in the morning when I was out walking in my neighborhood or driving out in the country to see what I could hear. And I ended up going out just about every day between July 26th and August 26th. Ended up going to 48 different locations in Erie County. And at most sites, I spent at least 10 to 15 minutes there. At some locations, if they were good places to walk, I'd sometimes spend a little bit more time. And some of the locations I ended up going back to a second time. The locations were all publicly accessible areas where there were parking lots right next to woods or trails that I could navigate into the woods. And these were all were mixed between urban, suburban, and rural locations. I did not include Presque Isle State Park because I think we already knew quite a bit about the owls that are out at Presque Isle. The tools that I used to do this work was basically my cell phone and a little notebook, and apps that are available for cell phones nowadays provide some good tools. I had a NIOSH sound level meter app that I used to check what the background noise levels were at all the locations. And also, if I did hear owls, I would use a little app that was a voice recorder on my cell phone to try to get recordings. What I typically recorded, though, was more crickets and katydids and frogs than I did owls. I used eBird to keep track of all of my positive observations or listening successes for owls. And I have to confess, I've become addicted to bird watching again, and I'm preparing to retire here and go bird watching even more often. And eBird gives me a good way to keep track of everything. What I found as the most frequently observed owl was the eastern screech owl, and 7 different locations during the month. I used a filter with eBird Explorer mode to just have July and August. So most of these were my observations indicated when I focused on the map of the screech owl observations. The one over in Conneaut was somebody else's, not mine. But 7 different locations. And my most exciting screech owl morning was at Northeast Township Conservation Park, near the mouth of 20 Mile Creek, where I detected a pair of screech owls, possibly more than a pair, and was able to get a pretty decent sound recording. I'm not going to attempt to play the recording, but all of the records on eBird are publicly accessible. So if you just look into Erie County or do the Explore feature with the eBird thing, you don't have to log in or anything, but you'd be able to find this checklist for August 16th and listen to both the monotonic trill and the descending trill of 2 different screech owls that I spent a good 10, 15 minutes just trying to get a decent recording and getting in the right spot to hear them. But it's a neat spot to go for birding, and there's often steelhead fishermen there in different parts of the year too, although not too many steelhead fishermen before sunrise. One of the places that surprised me that I found screech owl was at Roma Park. And I discovered it one morning when I was sitting in the parking lot right behind Tops with my windows down, and heard a couple of sounds that I knew were screech owls. But I came back several days later to try again and walk back into the woods deep enough just to the north of the back of Tops, and got a decent recording there. And there I was picking up a different kind of vocalization. They have this multiple syllable chuckle or rattle type call that I picked up. And it's kind of cool how eBird translates your sound recordings into a visual pattern, which sometimes helps to kind of know where you have to turn up the volume to hear something that you've captured. This is just a Google Earth image, April 2016, to kind of show you the patch of woods behind Tops, which is just on the south end of 38th Street, or the east end of 38th Street, close to the Bayfront connector. The next most frequently observed owl was the barred owl, which I picked up at 6 different locations. And I've marked on here the things that appeared that weren't my observations, including some barred owl records that month, or that month period, by Brian Zimmerman and Linda Susko. And interestingly, barred owls were not uncommonly detected close to the city or in the city. And I had a few locations where I had exciting moments when I had a pair of barred owls that I could listen to and try to record at State Game Lands 263, which is just way out close to the Warren County line, north of Corey, a couple there. And then just about 3 or 4 blocks from my house, I can walk to this place. It's a little undeveloped park called Glenwood Park that's sort of connected on the opposite side of the road of Glenwood Park Avenue to the Erie Zoo. And I thought that there should be barred owls in this one patch of woods, because it's becoming old growth forest, and it just looked like it would be prime habitat for these owls. And what I found there one morning, I just walked in a trail, maybe 100 meters from Elliott Road into the woods, and detected an adult pair having this weird kind of exchange of noises that sounds sort of like dragging your fingernail across a chalkboard, but it's like a wheezing sound that they make. And I picked that up, and you can kind of see the shadow patterns here that indicated the pair. I guess they were talking to each other, saying, "Who's that idiot, down there holding up his cell phone in the air?" This is just a Google Earth image of the patch of woods I'm talking about. And there is a lot of mature eastern hemlock in these woods. And I'm starting to see a pattern at places where I'm detecting barred owl. There's almost always at least, half a dozen or more hemlock trees that are older and more mature. So I think maybe they have some importance in the ecology of these owls. Great horned owl, I only saw one or heard at one location, and that was Siegel Marsh, or State Game Lands 218. And the other people during the same month period that I was doing my survey reported great horned owls too at places other than Presque Isle, including Jamie Hill out near Waterford, and Jennifer Farrick near Edinburgh Lake, and Ken Anderson, also sort of close to the city. And I just had to share, this was a morning I'll never forget. I was out at Game Lands 218, got there pretty early, and was walking along a little trail just off a May Road parking lot, and was able to hear all three different species of owls at one location. And my recordings weren't the greatest, but it was still kind of an exciting moment, and it was a pretty sunrise afterwards. So. And the other thing I just want to point out is you do hear other birds other than owls when you're out there in the woods in the dark. And most of the diversity doesn't really pick up until a little bit before sunrise. But I learned a lot about what species of songbirds are the earliest risers. And around here, the wood pewee kind of, I think, gets the award, and cardinals kind of second place for being the ones that you're most likely to hear before sunrise. So to wrap this up, overall, I had a fairly low frequency of detection, only a little bit more than a fourth of the sites. I actually detected owls, but that doesn't mean that they're not there. There's no question from the background data on noise that I collected that higher background noise levels due to wind and traffic makes it harder to hear them. And listening sessions longer than 10 to 15 minutes, you're more likely to detect an owl too. And I just reinforce, if you're teaching an ornithology class, you got to get your students out there at sunrise, because that's when you hear the most interesting diversity. I'd like to repeat this at other seasons, although I don't know if I'm going to have the energy to do this in the middle of the winter. I'd like to analyze the background noise data that I have, and I'd like to get a hold of some passive acoustic monitoring equipment. I discovered listening to Amber Stillwell's talk yesterday that there's things you can hang out on trees in the woods and record the vocalizations of things remotely. So I'm going to try to get a hold of some of that equipment. So thanks, Jeanette, Amber, and the Regional Science Consortium for providing this opportunity for me to share. It was fun.
Thank you so much, Mike. Great talk. We do have a question for you. It is actually from Amber. She would like to know, did you complete any observations at Frontier Park or on campus at Mercyhurst?
Yes, I did try both locations repeatedly and wasn't fortunate enough to detect any, but I wouldn't doubt that there could be screech owls at Mercyhurst.
All right, thank you again. We're gonna move on into our next talk. Up next, we have John Titus from SUNY Fredonia, and he's gonna talk to us about forest change in forest swamps in the College Lodge and campus woodlot in Chautauqua County. Go ahead, John.
Hello? Can you see the screen? Okay. Hi. My name is John Titus, and I'm in the biology department at SUNY Fredonia. And so I'd like to speak to you about forest change in this era of global change. And this research that I'm going to be talking about took place at the College Lodge Nature Preserve and at Chautauqua County Wetlands. So the College Lodge Nature Preserve is a high quality forest with an intact canopy. There are more than 500 plants. Yes?
Sorry, we cannot see your screen right now. Could you try re-screen sharing?
So there's nothing at the bottom to do that with. This is why I wish we had a little more time in the beginning, but let's see what we can do here. Nothing's happening when I click the Zoom button. Okay. So there's no button for sharing at all. On this.
We're checking up on things on our end. I'll be working with you in just a second.
After you click the screen share button, there should be a little pop-up that will ask which screen you would like to share.
Which one do I click?
It should be a green button at the bottom of the Zoom
No.
panel.
There's no green button there. So, I mean, I don't see anything. I just see click open meetings in the dialog box, which I don't see the dialog box. Now I have, well, I can see, now I can see all of you. And it says I have video and, okay, there's a share screen now.
There we go. Now you can just go back to your presentation. Yeah, that's working.
Okay.
Thank you. Sorry about that.
No, that's okay. We just started, you know, after 20 up, so it was kind of inevitable. So let's, I'll start again. My name's John Titus, and I'll be speaking about global change, I mean, forest change in this era of global change. And this research took place at the College Lodge and at some swamps in Chautauqua County. So I'll tell you a little bit about the College Lodge. It's a very diverse place with more than 500 plant species and 200 acres. There's many new species for the county, quite a few rare species, and a really remarkable assortment of different plant communities. Because of this, you have very rich fauna as well, with lots of salamander, bird, and bat species. There's also an extensive area of old growth with those many emergent properties that old growth has, including complex mycorrhizal networks. So the College Lodge is part of this county-wide plot network that I have to study forest change in this era of global change. So what are some of the different factors in global change today? Why is the globe changing? One of them is the non-native invasive plant species. And these species crowd out our native species, preventing tree regeneration, reducing wildlife resources, and they really do not contribute to the web of life. These are the major concern of land managers today and are enabled by our very high deer populations. How do these non-native invasive species get around? Well, by landscaping and mowing, which are good to avoid if possible, by the spreading of gravel and mulch, by ATVs and other forms of transportation, and birds, wind, and water. We'll bring them into, all of these will bring them into nature preserves. So some of the other invasive species issues present in the region are beech bark disease and beech leaf disease. Beech bark disease has been here a long time. This is caused by the European scale insect and is very different from the other diseases listed here because there are resistant beeches and is a very slow killer. Beech leaf disease is relatively new. It's believed to be viral and does have 100% mortality of young beech. There's also hemlock woolly adelgid, which at present is only known from one location in Chautauqua County, which is on the SUNY Fredonia campus. And then emerald ash borer, which you all know quite well and has killed hundreds of millions of ashes in New York State. So two more factors of forest change are deer. We have very high deer populations due to the lack of predators. So all edible plants are gone from the forest understory. And actually there's some evidence that, hunting by humans actually increases deer populations. But in our forests, DEC and other agencies manage for very high deer populations. I do have deer exclosures to look at those interesting plant species that do pop up when deer are excluded. And lastly, of course, climate change, which is causing a shift in plant ranges, animal ranges, and in phenology. So methods for these plots that I have, at the College Lodge, there are 14 of them. They're 900 meters squared, and every tree is tagged. And we measure the diameter of the trees annually, assess the condition. For example, is there birch bark disease or other kinds of, health issues, things like this. Vines, snags, and down woody debris. When do the trees die? Why do they die? And then do they fall over or remain as a snag? And then I have 16 meter squared understory plots in each large plot, 3 of them, where I look at the cover and density and the height of the understory trees, shrubs, and herbaceous species. These are permanent plots. At the College Lodge, there are forests of different ages. There's young forests, which are 50 to 70 years old or so, and then medium age forests, medium old forests, and old growth forests. So if we look at some data, and here we're looking at basal area in those 4 age classes. And you can see how in the young forests, the maximum amount of basal area is in the smallest trees, 10 to 20 centimeters in diameter. So what is basal area? That is the amount of area occupied by the trees in a hectare. So if you imagine cutting a tree down and you measured the area of the cut stump, then you would add up all of that area of the trees in a hectare. So in a young forest, you'd expect that the youngest trees would have the greatest basal area. It takes a lot of small trees to make basal area. If we look at medium age forests, we can see how the forest is shifting towards more of a normal curve, with some of those larger trees now occupying more basal area. The medium old forests, we're starting to see this very classic shape of a normal curve with an attenuated tail for those larger trees. And we can see that there's a very large number of large cherries that make that remarkable, really high bar. And these cherries are really important for, of course, insect and bird diversity. If we look at the old growth forest, we can see the classic old growth shape in basal area, with the maximum basal area being at trees 30 to 40, 40 to 50 centimeters in diameter or so, but with trees of all age classes. So let's look at DBH change by DBH. What that means is, how fast are these trees growing at the different size classes? How much is their diameter changing from year to year? And we can see that the largest trees are by far growing the fastest. So for a long time, the forestry paradigm was that larger, older trees and old growth forests were decadent and stagnant and weren't growing. But a whole body of research taking place all across the country in old growth forests is really showing that the big old trees are by far growing the fastest. And you can see that the trees that are 70, 80 centimeters in diameter are growing 3 times faster than our small trees. So what does this mean for basal area? How much wood are these trees putting on? So what we can see is that 27 large trees is putting on as much wood. This is carbon sequestration, taking as much carbon out of the atmosphere as about 90 trees, 40 to 50 centimeters in diameter, and maybe 500 trees that are 10 to 20 centimeters in diameter, and would be many thousands of seedlings would be doing the same amount of carbon sequestration. So you can see why from this, if you're interested in taking carbon out of the atmosphere, you want to keep the trees you have. And it shows how tree planting efforts really are not going to affect carbon sequestration, because the trees that are planted are small, and it's going to be at least 50 years until they start removing appreciable amounts of carbon dioxide from the atmosphere. So you really want to keep the trees you have, especially the big ones. So now let's shift over to our swamp forests. And this research was done at 4 swamps in Chautauqua County with the same methods, same size plots, and the trees are tagged, and the diameter measured every year with our understory plots. So if we look at basal area here, we can see that in the top left, Bonita Swamp is pretty young. The swamp dates to when the trolley cars around Chautauqua Lake were abandoned. So you really have most of the basal area in the smallest trees. Bentley has a lot more trees and is somewhat older. So you can see that the diameters are beginning to shift. And then Elm Flats, you're beginning to get a more mature forest there. And Frog Valley, similar. And Frog Valley has some very large ashes. So that's why you see that kind of structure. There's definitely some older trees in both of those swamp forests. So if we look at DBH change by DBH, you can see that we see the same pattern as in the upland forest at the College Lodge. The largest trees are definitely putting on the most amount of diameter. You want to remember, in a big tree also, the tree is shifting from a cone shape to a columnar shape. So you're actually putting on a lot more wood higher up the tree. Now, if we look at basal area increased by DBH, it's not quite as dramatic as in the upland forests, but you still can see 14 large trees is putting on as much carbon, putting on as much wood as perhaps 200 trees, and of course, once again, many thousands of seedlings. So you would want to keep the big trees that you have. Now, let's look briefly at what's happening to these swamps. Well, this is percent canopy cover over time. And you can see that the forests are becoming much more open today. This is because of the death of ash trees from emerald ash borer. And so emerald ash borer arrived in these forests at different times. So in Bentley, there's really been a lot more emerald ash borer tree death. And the emerald ash borer showed up at Elm Flats and Frog Valley much more recently. So the trees are just beginning to die there. But overall, of course, the canopy is reducing. And we can also see this in the tree mortality with that huge increase in percentage of trees that have just died at Bentley especially. Bonita has fewer ashes. So of course, there's not as many ashes to die. And some of that tree death at Bonita is from American elms. And the tree death is just beginning at Elm Flats and Frog Valley. So what we want to look at now is what is happening to the understory. What kind of understory response are we having? So this is a pretty crazy looking graph, but you can figure it out if we spend just a minute on it. So what's happening is this is taking all the understory vegetation data and mashing it down to 2 dimensions in a multivariate analysis. So if we go and look at the far right corner, you can see that that plot is plot 1-1 in the year 2012. Then the further away the vegetation is in a plot, the farther away the 2 plots will be. So 2 plots that are almost identical will be next to each other. 2 plots that have very different plant species in them will be far apart. So you can see from 2012 to 2014, the vegetation did change some, and there was a shift up that blue line. And then from 2014 to 2015, the vegetation basically changed back close to where it was before. And what you can see in all these plots at Elm Flats is that the vegetation's kind of been going around and around and around. And this is, of course, in response to weather each year. Drier years, wetter years, and things like this will shift understory vegetation. What we're not seeing is any major directional shift from the death of the ashes. Whether or not that will occur in the future, I don't know. So if you're wondering what would a directional shift look like, we can see it much more clearly on this graph, where on Mount St. Helens, the power of the succession is strong. So from 2002, all those plots are identical. And as the vegetation matures in succession, the plots all change in a similar way, going towards the left. Because those plots have different treatments on them, though they do diverge a little, but succession is a dominant force, really directionally changing all the plots in the same way. So, in conclusion, it's clear that the older, bigger trees grow faster and really are putting on the most amount of wood, really drawing that CO2 out of the atmosphere. So if you're interested in carbon sequestration, keep the forests you have. Planting seedlings and saplings is great for many reasons, but it's not going to have a big effect on carbon sequestration for many, many decades. Beech bark disease, hemlock woolly adelgid, and especially emerald ash borer, deer, and climate change are changing our forests quite rapidly. So far, changes in the overstory are clear. In the understory, the patterns are not yet clear. I showed the example from Elm Flats for that. When you're managing these forests, you really want to use the best available science to have the best management practices. Avoid logging, because that will disrupt the ecosystem, both above and below ground. Eliminate your old growth trees and those species that depend upon them. Introduce non-native invasive species, etc. There's also really important to have effective invasive species management, and if possible, manage your deer. So, okay, so if you have any questions, please ask.
All right, John, thank you. Great presentation. We do have a question for you.
Okay.
Are your findings of faster DBH growth by large trees documented in other types of forests?
yes, they've now been documented all across the country, because for a long time, the belief was that older forests were stagnant, but actually nobody was measuring the biggest trees. So now in forests all across the country, very similar patterns have emerged, with those big trees really are putting on that diameter. And because they're changing from more of a cone shape to a columnar shape, actually there's even more wood going on, adding to the tree higher up the tree.
All right, thank you so much again. That is our only question. So we are going to go ahead and finish out this session for today.
Yep.
We will return at 1 o'clock after our lunch break, and that is when we will have our student awards. So please join us for 1 o'clock for our student awards. Thank you, everyone.
It's no secret. Education is the key to success. Serving more than 2,200 families, WQLN brings learning to life by combining PBS Kids programs with reading and hands-on activities.
PBS Learning Triangle, I feel like it's a simple step for parents to grasp. So it's not something over their head or too complex.
Watching my students for the 4 weeks develop a little bit more of their personalities, have the opportunity to read and have the opportunity to be excited.
People say it takes a village to help raise students. It also takes a village to educate them. So WQLN coming in to partner with our kids helps those kids get those strategies and the parents the strategies that they can help their kids at home.
You're part of a community and we're all here together and we all care about the children and the future of the community.
To become an EITC partner and support this program, visit WQLN.org.
ETD Photography is an Erie-based media and creative services company by Eric Dye, creating media to expand your reach and further your goals. With a diverse project history, ETD Photography brings unique and comprehensive creative media to Erie individuals, businesses, and organizations. Services include photography, videography, web design, logos, podcast production, YouTube channel production, live streaming, and more. Check out our website at etdphotography.com.
Hello, my name is Dr. Jeanette Schnars, and I'm the Executive Director of the Regional Science Consortium. And I'm here at Presque Isle State Park today exploring the priority wetlands that we've been working on with our collaborators to restore over the last decade. Now, wetlands are a critical ecosystem that help protect Lake Erie and other bodies of water that they're connected to from runoff, and that would include sediment in the runoff, nutrients, and pollutants. And then wetlands also serve as critical habitats for all different kinds of species, including plants and insects, fish, birds, and other mammals that live here. Today we're going to investigate the relationship between humans and wetlands and how this has changed over time. So wetlands, once thought of as swamps or just pools of stagnant water that were unsightly, were often destroyed as a result of construction and development. However, today their importance is realized, and a healthy wetland exhibits high plant diversity and animal diversity. However, due to invasive species and some other human interactions, some wetlands are not considered healthy, and that's where we come in as researchers to help restore these areas.
My name is Holly Best. I'm one of the assistant park managers here at Presque Isle State Park. I work with the resource management program. A large part of that program, we try to manage invasive species that are growing on the park. Some of the main targets are Phragmites and narrowleaf cattail. Phragmites are specifically important to manage because not only are they very prolific when they come into an area and take it over, they spread through rhizome, they also spread through seeds. They also are allelopathic, so they actually put poison or toxin down into the soil and prevent anything else from growing. So that makes a monoculture of that plant, which for species diversity is very detrimental. At this park, we're very fortunate that we are able to use herbicide to help control these species. We have done everything from have interns with backpack sprayers, doing a very focused attempt, all the way up to helicopters actually doing kind of broadcast spraying over some of those very large monoculture areas. We're fortunate that we're able to use that as a control technique because if you don't have that ability, it's very hard to control these species and try to return these areas back to their native environments.
My name is Jen Salem. I'm the horticulture specialist for the Regional Science Consortium, and I'm also the founder of Go Native Erie. Go Native Erie is a program that operates under the Regional Science Consortium, and it helps educate the public about the benefits of native plant species and using natives in their gardens. Native plants are actually, they're defined in two ways. They are plants that were discovered here growing in North America at the time of European settlement. But a better definition of that is that native plants are a plant that has been in an area for a long time and it has evolved with something else to form an important relationship.
We are in the Regional Science Consortium greenhouse at the Tom Ridge Environmental Center. So we use this for propagation. So we get things growing and started here.
So this is the beginning of the process. So every year I'm looking at what seeds can I grow, what did well. Every year we're trying to increase our diversity and the amount of plants that we grow, but also pay attention to things that are going to do well. It's not just about quantity, it's also about quality. So now we're down at the Regional Science Consortium's cold frame greenhouse on Presque Isle State Park. And this is used as a distribution center and holding area for all the plants that are produced in the Regional Science Consortium propagation greenhouse. So when plants grow up to be a certain size and they're ready to be planted in a wetland, they are brought down here and held at this site and cared for. Then when we have groups of volunteers and employees that can come and help, we decide what plants are going into each of the restoration locations, and we'll just load these all up on a truck and have a planting day.
All right, so I hope you enjoyed the tour of our wetlands and all the work that we're doing with our collaborators to help restore these areas. So if you'd like to learn more about this project or other projects, please visit the Regional Science Consortium's website at www.regsciconsort.com. Hello, my name is Dr. Jeanette Schnars. I'm the Executive Director here at the Regional Science Consortium. So the RSC is a collaborative. We are made up of colleges and universities, state and federal agencies, K-12 school districts, as well as other nonprofits with similar missions. And some of the research we do focuses on water quality, especially here at our swimming beaches, harmful algal blooms, different types of fishery, including yellow perch and walleye, invasive species, wetlands, native plants, and even shipwrecks and exploration of other submerged cultural resources in Lake Erie. If you get a chance today, make sure you ask at the front desk for a tour to learn more about the different projects that we have going on back there. So we use these research projects as fuel for some of our education and experiences that we offer to students in our school district membership. So these students get to experience things with invasive species, with our native plants, with fisheries, and we even have other experiences that they participate in, including a college prep workshop series. To find out more about our research and education, and also to find out if your organization, school district, college or university is a member of the RSC, just check out our website at regsciconsort.com. Hi, I'm Dr. Jeanette Schnars. I'm the Executive Director of the Regional Science Consortium, and I'm standing here on the shores of Lake Erie, which is known as one of the best sport fisheries in all of the Great Lakes.
and 2 of the most popular species include yellow perch and walleye.
The fishery historically has always been great here, but it has had some pressures in the past, including over-harvesting of certain species and other things like invasive species. These invasives have really paid a toll on some of our best sport fisheries.
Hi, my name is Greg Andreso, and I'm a biologist from Gannon University here in Erie. And for about the last 20 years, my students and I have focused on the fish population in Presque Isle Bay behind me. A lot of our work has focused on the round goby. The round goby is a non-native species from the Black Sea, Caspian Sea part of Eurasia. And it was first introduced into Lake Erie in the early 90s by ballast water in freighters. So these freighters brought these fish across the Atlantic and offloaded them unintentionally into the Great Lakes. So a lot of the work that we've done is focused on round gobies and their interactions with 2 species of mussels, which are actually non-native as well, what we commonly call zebra mussels, and there's actually another species that's closely related called quagga mussels. And our work has really looked at predation by round gobies on these Dreissenid mussels, the zebra mussels and quagga mussels. Round gobies eat things like smallmouth bass eggs, so they've had an influence on the ecosystem. They're here to stay. I don't think we're ever going to get rid of them. And part of my job and the job of my students has been to try to better understand their roles in that ecosystem.
Hi, I'm Dr. Casey Bracha-Wilson from Allegheny College. I am studying the invasion of round gobies from the Lake Erie watershed into the French Creek watershed, which is a stream that ultimately flows to the Mississippi River. So this invasion is a really important one that we've been studying and monitoring since they've first been introduced, probably through some type of fishing activity, whether it was through a boat or through bait bucket transfer or something like that. We have a lot of projects going on, including what the round gobies are eating, how they're impacting native fish through behavior and aggressive interactions, also how they can change communities through eating macroinvertebrates and other fishes and their eggs and those types of things. French Creek is an extremely important stream in Pennsylvania. It houses more diversity than any other stream in the state, including many threatened, endangered, or species of concern. So round gobies have recently been known to eat native mussels in the juvenile phases when they're very small. And so a lot of the mussels in French Creek are threatened or endangered species. And so the impacts to mussels from round gobies, we don't know exactly how catastrophic that will be, but it could be really bad for the French Creek watershed.
The Pennsylvania Fish and Boat Commission regulates fishing here in Erie, Pennsylvania, and on the waters of Pennsylvania for all of Lake Erie. Lake Erie has been subject to a lot of invasive species throughout the years, all of which have unknown effects when they first get here, and it's only through their actual arrival that we're able to manage them. 2018, the Pennsylvania Fish and Boat Commission joined with our cooperators in Ohio, Ontario, and New York and started tagging walleye here off the shores of Pennsylvania, right here off of Walnut Creek Marina, looking at spawning site fidelity as well as fish movement throughout the summer months and even into the winter. To date, 41 walleye have been tagged here at Walnut Creek and released back into Lake Erie, and we've watched those fish travel for almost 2 years now. We have 21,000 detections of those fish in the last 2 years. And with that, we were able to see if these fish do exhibit spawning site fidelity and return to Pennsylvania waters to spawn. The Pennsylvania Fish and Boat Commission operates the Lake Erie Boat Angler Survey annually from May 1st to October 31st. We run a bus route style creel survey in which we sample anglers and boaters from Walnut Creek, Lampe Marina, East Avenue, Boat Launch, and Northeast Marina. In this process, we count all the boats that launch, and we count all the boats that land at those marinas during the times that we're there. And while we're there, we try to interview all the anglers that land. We try to find out some economical information from them, where they have traveled from by getting their zip code, how many folks were here, how many folks fished, how many rods they used, how long they fished, what they were targeting, and what they caught. And from this information, we can start to come up with a figure of how many fish are successful, or how many fishermen are successful, and how many fish are harvested from Lake Erie annually by our recreational anglers. The Pennsylvania Fish and Boat Commission is very interested in sustainability. So with all this information and all this work we do throughout the summer with the other jurisdictions that manage Lake Erie, we're able to make sure that the fishery is sustainable and that the anglers have the best opportunity of success every time they go out in the water.
So as you can see, our evolving relationship with the fisheries and the people that live here is so important, both historically as well as currently. And researchers will continue to work on the different issues that arise and challenge our sport fishery, and managers will continue to manage and sustain these populations for the future.
It's no secret, education is the key to success. Serving more than 2,200 families, WQLN brings learning to life by combining PBS Kids programs with reading and hands-on activities.
People say it takes a village to help raise students. It also takes a village to educate them.
You're part of a community, and we're all here together, and we all care about the children and the future of the community.
To support the program, visit WQLN.org.
ETD Photography is an Erie-based media and creative services company by Eric Dye, creating media to expand your reach and further your goals. With a diverse project history, ETD Photography brings unique and comprehensive creative media to Erie individuals, businesses, and organizations. Services include photography, videography, web design, logos, podcast production, YouTube channel production, live streaming, and more. Check out our website at etdphotography.com. The Regional Science Consortium is a collaborative of colleges, universities, state and federal agencies, K-12 school districts, and nonprofits. The mission of the RSC is to promote and enhance our knowledge and understanding of the Lake Erie and Ohio River Basin ecosystems through research and education. The RSC also provides educational lessons and experiences for students, including forensic science escape rooms, hackathons, and a college prep workshop series. Each year, the Regional Science Consortium hosts an annual research symposium to highlight local research and projects. The Regional Science Consortium's 16th Annual Research Symposium, November 4th through 6th, will be live on YouTube at regscitv.com. Presenters will highlight local research on water quality, harmful algal blooms, wetland restoration, invasive species, fisheries, and more. David Frew and Jerry Skripczak will present Wednesday evening, November 4th, and PADCNR Environmental Education Specialist will present November 5th. All are welcome. Details online at regsciconsort.com. Supported in part by WQLN.
this handheld unit against the buoy, and that helps us determine if we need to calibrate it or not, make sure it's measuring correctly. Temperature is 22.250 degrees Celsius. This unit right here is our weather station. Measures things like wind, air temperature, even takes data on rain. In the center of the buoy right here, we have our beacon. That light is a white light that comes on at an interval of every 2 seconds to make sure that mariners in the evening or at night are aware of the buoy and can see it. Our Garmin GPS unit helps us keep track of the buoy. If it were to ever break free, we would be able to find it. We use these solar panels here to recharge the marine batteries inside the core of the buoy. So they take in energy from the sun every day and recharge those every night. Our antenna right here helps us with cellular reception, so we transmit our data every 20 minutes through a cell phone connection or a cellular modem back to our computer that processes the data. And then on the opposite end of the buoy, we have a video camera, and that video camera allows us to get 20 or 10-second clips of the conditions out here, the lake conditions, and update that to our website so people can see what those conditions are. Inside, in between all of these solar panels, is the wave meter. And that wave meter is measuring these waves, which are pretty decent today. And those waves are being monitored over a 10-minute interval, and then it will give you the maximum wave height as well as the average wave height during that time period. Now, under the buoy is what's called a water quality sonde, similar to what we were just using and dropped in the water. And that's going to measure things like temperature of the water, pH, dissolved oxygen, turbidity, and blue-green, the presence of blue-green algae. So the Regional Science Consortium has 2 weather stations on land and 4 buoys that they put out each year. This is our nearshore buoy, 2.5 miles off of the lighthouse at Presque Isle State Park. We also have another buoy similar to this, a little bit smaller, that we deploy off Walnut Creek to the west of here. And then we have 2 smaller beach buoys that we deploy off Beach 2 and Beach 6. Those beach buoys are just measuring parameters about the water, like temperature and the chemistry of the water, and that helps us with predicting if there's blue-green algae, harmful algal blooms, bacteria in the water, so we use that for a lot of research. The buoys are deployed in May, so as early as we can get out here, and then we usually retrieve them around October at the end of the boating season. Okay, so now we're back to my office, and this is where the information from our weather stations and our buoy come back into the computer and then get processed and eventually to the website. So this is the software that runs the data that comes in from the buoy, and it does some calculations to figure out things like the maximum wave and average wave, as well as your maximum wind, your maximum rain, and then averaging those data points as well. So right here you can see we're looking at the nearshore buoy data. We have a lot of the information you might see on the website, as well as some information that we need here just to make sure things are operating correctly. And we can scroll through any of our weather stations or buoys, and we can also make sure they're all updating when they should. So this will scroll new data about every 20 minutes. And then this data will be processed, and I'll just click on our website. This is PALakeErieBuoy.com. And then if you come into our website, you can see our weather stations as well as our different buoys. And this is the nearshore buoy that we were just visiting. We click on that, and it will go ahead and load the data, and we can see how big the waves are, how fast the wind is blowing, and what kind of temperatures we have out there. So right now, looking at it, we have about a maximum of 2.8 foot waves, about an average of 1.6. And when we were just out there earlier today, we probably saw good 2 foot waves with a little bit of white capping. All of the data looks good and current.
and that's how we process the data.
So another project that we work on at the Regional Science Consortium is looking at barotrauma and yellow perch. And yellow perch is a really important fishery to this area. And it's one that reproduces naturally, so we want to make sure we take care of it. And one of the issues is that late in the summer, yellow perch can be as deep as 50, 60, even more feet of water. And when anglers pull them up, a lot of times their swim bladder will expand, which pushes on their stomach, and their stomach protrudes through their mouth. And there's other symptoms that they experience as well, such as bulging eyes, hemorrhaging around the fins. And so what we're trying to do is see if they are capable of recovering from this barotrauma, the stress. And one of the ways that we do this through some of our research is by putting them in these cages. And with these cages, it's almost like an elevator, and we can sink them right back down to the bottom pretty quickly. Now on these cages, we outfit them with a GoPro camera across the top, and we can monitor what they're doing for the first hour that they're submerged. And we have found that within about 10 to 15 minutes, these perch will right themselves. So when we put them down, they're kind of belly up and bloated. So in about 10 or 15 minutes, they'll right themselves or turn themselves right side up again. Their stomach goes back into their bodies, and they're able to swim around like a normal fish. So then the next question is there any latent or delayed mortality? Did they have any injuries inside their bodies? And we found after 3 days, they are still healthy fish and able to overcome this stress. So we'll go ahead and we'll deploy this cage. So when we're out here, we'll collect perch by angling. We'll take that perch, we'll put it in the cage, we'll lace the cage up, and then we'll go ahead and put it down to the bottom. So when we pull these cages back up after 3 days, the perch are still healthy fish and they were capable of overcoming that stress. However, that's the story we found in the beginning of the season when the bottom temperatures were still pretty cool. As summer goes on, the bottom temperatures in the water get warmer, and as temperature increases, dissolved oxygen decreases. And when this happens, that's just another stress that's put on these fish. So we find that when we pull these cages up, we have about 100% mortality. And so between the barotrauma as well as low dissolved oxygen, high temperatures, these fish just can't overcome all of those stresses. So early in the season, real early in the spring, we might find yellow perch as shallow as 17 feet of water. And as spring comes on and moves on into summer, we find that these fish migrate from the shallow waters out into the deeper waters. And that's how we can see that, the seasons are changing and that these fish move with the change in temperature, other fish as well, and they move out into the deeper waters by the time we get to summer.
It's no secret, education is the key to success. Serving more than 2,200 families, WQLN brings learning to life by combining PBS Kids programs with reading and hands-on activities.
PBS Learning Triangle, I feel like it's a simple step for parents to grasp. So it's not something over their head or too complex.
Watching my students for the 4 weeks develop a little bit more of their personalities, have the opportunity to read and have the opportunity to be excited.
People say it takes a village to help raise students. It also takes a village to educate them. So WQLN coming in to partner with our kids helps those kids get those strategies and the parents the strategies that they can help their kids at home.
You're part of a community and we're all here together and we all care about the children and the future of the community.
To become an EITC partner and support this program, visit WQLN.org.
ETD Photography is an Erie-based media and creative services company by Eric Dye, creating media to expand your reach and further your goals. With a diverse project history, ETD Photography brings unique and comprehensive creative media to Erie individuals, businesses, and organizations. Services include photography, videography, web design, logos, podcast production, YouTube channel production, live streaming, and more. Check out our website at etdphotography.com.
Hello, my name is Dr. Jeanette Schnars, and I'm the Executive Director of the Regional Science Consortium. And I'm here at Presque Isle State Park today exploring the priority wetlands that we've been working on with our collaborators to restore over the last decade. Now, wetlands are a critical ecosystem that help protect Lake Erie and other bodies of water that they're connected to from runoff, and that would include sediment in the runoff, nutrients, and pollutants. And then wetlands also serve as critical habitats for all different kinds of species, including plants and insects, fish, birds, and other mammals that live here. Today we're going to investigate the relationship between humans and wetlands and how this has changed over time. So wetlands, once thought of as swamps or just pools of stagnant water that were unsightly, were often destroyed as a result of construction and development. However, today their importance is realized, and a healthy wetland exhibits high plant diversity and animal diversity. However, due to invasive species and some other human interactions, some wetlands are not considered healthy, and that's where we come in as researchers to help restore these areas.
My name is Holly Best. I'm one of the assistant park managers here at Presque Isle State Park. I work with the resource management program. A large part of that program, we try to manage invasive species that are growing on the park. Some of the main targets are Phragmites and narrowleaf cattail. Phragmites are specifically important to manage because not only are they very prolific when they come into an area and take it over, they spread through rhizome, they also spread through seeds. They also are allelopathic, so they actually put poison or toxin down into the soil and prevent anything else from growing. So that makes a monoculture of that plant, which for species diversity is very detrimental. At this park, we're very fortunate that we are able to use herbicide to help control these species. We have done everything from have interns with backpack sprayers, doing a very focused attempt, all the way up to helicopters actually doing kind of broadcast spraying over some of those very large monoculture areas. We're fortunate that we're able to use that as a control technique because if you don't have that ability, it's very hard to control these species and try to return these areas back to their native environments.
My name is Jen Salem. I'm the horticulture specialist for the Regional Science Consortium, and I'm also the founder of Go Native Erie. Go Native Erie is a program that operates under the Regional Science Consortium, and it helps educate the public about the benefits of native plant species and using natives in their gardens. Native plants are actually, they're defined in two ways. They are plants that were discovered here growing in North America at the time of European settlement. But a better definition of that is that native plants are a plant that has been in an area for a long time and it has evolved with something else to form an important relationship.
We are in the Regional Science Consortium greenhouse at the Tom Ridge Environmental Center.
So we use this for propagation. So we get things growing and started here. So this is the beginning of the process. So every year I'm looking at what seeds can I grow, what did well. Every year we're trying to increase our diversity and the amount of plants that we grow, but also pay attention to things that are going to do well. It's not just about quantity, it's also about quality. So now we're down at the Regional Science Consortium's cold frame greenhouse on Presque Isle State Park. And this is used as a distribution center and holding area for all the plants that are produced in the Regional Science Consortium propagation greenhouse. So when plants grow up to be a certain size and they're ready to be planted in a wetland, they are brought down here and held at this site and cared for. Then when we have groups of volunteers and employees that can come and help, we decide what plants are going into each of the restoration locations, and we'll just load these all up on a truck and have a planting day.
All right, so I hope you enjoyed the tour of our wetlands and all the work that we're doing with our collaborators to help restore these areas. So if you'd like to learn more about this project or other projects, please visit the Regional Science Consortium's website at www.regsciconsort.com.
Hello, my name is Dr. Jeanette Schnars. I'm the Executive Director here at the Regional Science Consortium. So the RSC is a collaborative. We are made up of colleges and universities, state and federal agencies, K-12 school districts, as well as other nonprofits with similar missions. And some of the research we do focuses on water quality, especially here at our swimming beaches, harmful algal blooms, different types of fishery, including yellow perch and walleye, invasive species, wetlands, native plants, and even shipwrecks and exploration of other submerged cultural resources in Lake Erie. If you get a chance today, make sure you ask at the front desk for a tour to learn more about the different projects that we have going on back there. So we use these research projects as fuel for some of our education and experiences that we offer to students in our school district membership. So these students get to experience things with invasive species, with our native plants, with fisheries, and we even have other experiences that they participate in, including a college prep workshop series. To find out more about our research and education, and also to find out if your organization, school district, college or university is a member of the RSC, just check out our website at regsciconsort.com.
Hi, I'm Dr. Jeanette Schnars. I'm the Executive Director of the Regional Science Consortium, and I'm standing here on the shores of Lake Erie, which is known as one of the best sport fisheries in all of the Great Lakes. And two of the most popular species include yellow perch and walleye. The fishery historically has always been great here, but it has had some pressures in the past, including over-harvesting of certain species and other things like invasive species. These invasives have really paid a toll on some of our best sport fisheries.
Hi, my name is Greg Andreso, and I'm a biologist from Gannon University here in Erie. And for about the last 20 years, my students and I have focused on the fish population in Presque Isle Bay behind me. A lot of our work has focused on the round goby. The round goby is a non-native species from the Black Sea, Caspian Sea part of Eurasia, and it was first introduced into Lake Erie in the early 90s by ballast water in freighters. So these freighters brought these fish across the Atlantic and offloaded them unintentionally into the Great Lakes. So a lot of the work that we've done is focused on round gobies and their interactions with two species of mussels, which are actually non-native as well, what we commonly call zebra mussels, and there's actually another species that's closely related called quagga mussels. And our work has really looked at predation by round gobies on these dracaenid mussels, the zebra mussels and quagga mussels. Round gobies eat things like smallmouth bass eggs, so they've had an influence on the ecosystem. They're here to stay. I don't think we're ever going to get rid of them. And part of my job and the job of my students has been to try to better understand their roles in that ecosystem.
Hi, I'm Dr. Casey Bracha-Wilson from Allegheny College. I am studying the invasion of round gobies from the Lake Erie watershed into the French Creek watershed, which is a stream that ultimately flows to the Mississippi River. So this invasion is a really important one that we've been studying and monitoring since they've first been introduced probably through some type of fishing activity, whether it was through a boat or through bait bucket transfer or something like that. We have a lot of projects going on, including what the round gobies are eating, how they're impacting native fish through behavior and aggressive interactions, also how they can change communities through eating macroinvertebrates and other fishes and their eggs and those types of things. French Creek is an extremely important stream in Pennsylvania. It houses more diversity than any other stream in the state, including many threatened, endangered, or species of concern. So round gobies have recently been known to eat native mussels in the juvenile phases when they're very small, and so a lot of the mussels in French Creek are threatened or endangered species, and so the impacts to mussels from round gobies, we don't know exactly how catastrophic that will be, but it could be really bad for the French Creek watershed.
The Pennsylvania Fish and Boat Commission regulates fishing here in Erie, Pennsylvania, and on the waters of Pennsylvania for all of Lake Erie. Lake Erie has been subject to a lot of invasive species throughout the years, all of which have unknown effects when they first get here, and it's only through their actual arrival that we're able to manage them. 2018, the Pennsylvania Fish and Boat Commission joined with our cooperators in Ohio, Ontario, and New York and started tagging walleye here off the shores of Pennsylvania, right here off of Walnut Creek Marina, looking at spawning site fidelity as well as fish movement throughout the summer months and even into the winter. To date, 41 walleye have been tagged here at Walnut Creek and released back into Lake Erie, and we've watched those fish travel for almost 2 years now. We have 21,000 detections of those fish in the last 2 years, and with that we were able to see if these fish do exhibit spawning site fidelity and return to Pennsylvania waters to spawn. The Pennsylvania Fish and Boat Commission operates the Lake Erie Boat Angler Survey annually from May 1st to October 31st. We run a bus route style creel survey in which we sample anglers and boaters from Walnut Creek, Lampe Marina, East Avenue, Boat Launch, and Northeast Marina. In this process, we count all the boats that launch and we count all the boats that land at those marinas during the times that we're there. And while we're there, we try to interview all the anglers that land. We try to find out some economical information from them, where they have traveled from by getting their zip code, how many folks were here, how many folks fished, how many rods they used, how long they fished, what they were targeting, and what they caught. And from this information, we can start to come up with a figure of how many fish are successful, or how many fishermen are successful, and how many fish are harvested from Lake Erie annually by our recreational anglers. The Pennsylvania Fish and Boat Commission is very interested in sustainability. So with all this information and all this work we do throughout the summer with the other jurisdictions that manage Lake Erie, we're able to make sure that the fishery is sustainable and that the anglers have the best opportunity of success every time they go out in the water.
So as you can see, our evolving relationship with the fisheries and the people that live here is so important, both historically as well as currently. And researchers will continue to work on the different issues that arise and challenge our sport fishery, and managers will continue to manage and sustain these populations for the future.
It's no secret, education is the key to success. Serving more than 2,200 families, WQLN brings learning to life by combining PBS Kids programs with reading and hands-on activities.
People say it takes a village to help raise students. It also takes a village to educate them.
You're part of a community, and we're all here together, and we all care about the children and the future of the community.
To support the program, visit WQLN.org. ETD Photography is an Erie-based media and creative services company by Eric Dye, creating media to expand your reach and further your goals. With a diverse project history, ETD Photography brings unique and comprehensive creative media to Erie individuals, businesses, and organizations. Services include photography, videography, web design, logos, podcast production, YouTube channel production, live streaming, and more. Check out our website at etdphotography.com.
The Regional Science Consortium is a collaborative of colleges, universities, state and federal agencies, K-12 school districts, and nonprofits. The mission of the RSC is to promote and enhance our knowledge and understanding of the Lake Erie and Ohio River Basin ecosystems through research and education. The RSC also provides educational lessons and experiences for students, including forensic science escape rooms, hackathons, and a college prep workshop series. Each year, the Regional Science Consortium hosts an annual research symposium to highlight local research and projects. The Regional Science Consortium's 16th Annual Research Symposium, November 4th through 6th, will be live on YouTube at regscitv.com. Presenters will highlight local research on water quality, harmful algal blooms, wetland restoration, invasive species, fisheries, and more. David Frew and Jerry Skripczak will present Wednesday evening, November 4th, and PADCNR Environmental Education Specialist will present November 5th. All are welcome. Details online at regsciconsort.com. Supported in part by WQLN.
This piece right here is called a sonde, and it's the exact same thing that's under the buoy, and it measures temperature, pH, conductivity, dissolved oxygen, and so we measure this handheld unit against the buoy, and that helps us determine if we need to calibrate it or not, make sure it's measuring correctly. Temperature is 22.250 degrees Celsius. This unit right here is our weather station. Measures things like wind, air temperature, even takes data on rain. In the center of the buoy right here, we have our beacon. That light is a white light that comes on at an interval of every 2 seconds to make sure that mariners in the evening or at night are aware of the buoy and can see it. Our Garmin GPS unit helps us keep track of the buoy. If it were to ever break free, we would be able to find it. We use these solar panels here to recharge the marine batteries inside the core of the buoy. So they take in energy from the sun every day and recharge those every night. Our antenna right here helps us with cellular reception, so we transmit our data every 20 minutes through a cell phone connection or a cellular modem back to our computer that processes the data. And then on the opposite end of the buoy, we have a video camera, and that video camera allows us to get 20 or 10-second clips of the conditions out here, the lake conditions, and update that to our website so people can see what those conditions are. Inside, in between all of these solar panels, is the wave meter. And that wave meter is measuring these waves, which are pretty decent today. And those waves are being monitored over a 10-minute interval, and then it will give you the maximum wave height as well as the average wave height during that time period. Now, under the buoy is what's called a water quality sonde, similar to what we were just using and dropped in the water, and that's going to measure things like temperature of the water, pH, dissolved oxygen, turbidity, and blue-green, the presence of blue-green algae. So the Regional Science Consortium has 2 weather stations on land and 4 buoys that they put out each year. This is our nearshore buoy, 2.5 miles off of the lighthouse at Presque Isle State Park. We also have another buoy similar to this, a little bit smaller, that we deploy off Walnut Creek to the west of here. And then we have 2 smaller beach buoys that we deploy off Beach 2 and Beach 6. Those beach buoys are just measuring parameters about the water, like temperature and the chemistry of the water, and that helps us with predicting if there's blue-green algae, harmful algal blooms, bacteria in the water, so we use that for a lot of research. The buoys are deployed in May, so as early as we can get out here, and then we usually retrieve them around October at the end of the boating season.
Okay, so now we're back to my office, and this is where the information from our weather stations and our buoy come back into the computer and then get processed and eventually to the website. So this is the software that runs the data that comes in from the buoy, and it does some calculations to figure out things like the maximum wave and average wave, as well as your maximum wind, your maximum rain, and then averaging those data points as well. So right here you can see we're looking at the nearshore buoy data. We have a lot of the information you might see on the website, as well as some information that we need here just to make sure things are operating correctly. And we can scroll through any of our weather stations or buoys, and we can also make sure they're all updating when they should. So this will scroll new data about every 20 minutes. And then this data will be processed, and I'll just click on our website. This is PALakeErieBuoy.com. And then if you come into our website, you can see our weather stations as well as our different buoys. And this is the nearshore buoy that we were just visiting. We click on that and it will go ahead and load the data, and we can see how big the waves are, how fast the wind is blowing, and what kind of temperatures we have out there. So right now, looking at it, we have about a maximum of 2.8 foot waves, about an average of 1.6. And when we were just out there earlier today, we probably saw good 2 foot waves with a little bit of white capping. All of the data looks good and current, and that's how we process the data.
So another project that we work on at the Regional Science Consortium is looking at barotrauma and yellow perch. And yellow perch is a really important fishery to this area. And it's one that reproduces naturally, so we want to make sure we take care of it. And one of the issues is that late in the summer, yellow perch can be as deep as 50, 60, even more feet of water. And when anglers pull them up, a lot of times their swim bladder will expand, which pushes on their stomach, and their stomach protrudes through their mouth. And there's other symptoms that they experience as well, such as bulging eyes, hemorrhaging around the fins. And so what we're trying to do is see if they are capable of recovering from this barotrauma, the stress. And one of the ways that we do this through some of our research is by putting them in these cages. And with these cages, it's almost like an elevator, and we can sink them right back down to the bottom pretty quickly. Now on these cages, we outfit them with a GoPro camera across the top, and we can monitor what they're doing for the first hour that they're submerged. And we have found that within about 10 to 15 minutes, these perch will right themselves. So when we put them down, they're kind of belly up and bloated. So in about 10 or 15 minutes, they'll right themselves or turn themselves right side up again. Their stomach goes back into their bodies, and they're able to swim around like a normal fish. So then the next question is there any latent or delayed mortality? Did they have any injuries inside their bodies? And we found after 3 days, they are still healthy fish and able to overcome this stress. So we'll go ahead and we'll deploy this cage. So when we're out here, we'll collect perch by angling. We'll take that perch, we'll put it in the cage, we'll lace the cage up, and then we'll go ahead and put it down to the bottom. So when we pull these cages back up after 3 days, the perch are still healthy fish and they were capable of overcoming that stress. However, that's the story we found in the beginning of the season when the bottom temperatures were still pretty cool. As summer goes on, the bottom temperatures in the water get warmer, and as temperature increases, dissolved oxygen decreases. And when this happens, that's just another stress that's put on these fish. So we find that when we pull these cages up, we have about 100% mortality.
And so between the barotrauma as well as low dissolved oxygen, high temperatures, these fish just can't overcome all of those stresses. So early in the season, real early in the spring, we might find yellow perch as shallow as 17 feet of water. And as spring comes on and moves on into summer, we find that these fish migrate from the shallow waters out into the deeper waters. And that's how we can see that, you know, the seasons are changing and that these fish move with the change in temperature, other fish as well, and they move out into the deeper waters by the time we get to summer.
Thank you all for participating in the Regional Science Consortium's 16th Annual Research Symposium. Whether you are a presenter, judge, or audience member, your participation has made this year's event a great success. Obviously, by presenting through a virtual platform, it was a different experience. I miss being able to see everyone and chat about your work, research, and updates over the last year. I also missed being able to take people on research wing tours and highlight what we've been working on for the last year. However, change can be good, and this year's symposium, Real Science, brought to you virtually, embraced the use of technology to bring us together, including those who would not have been able to travel and see us in person. Our successes with this symposium, I just want to give you some numbers. After all, we are scientists. We had 55 talks, 25 posters, 99 presenters, 27 organizations represented, and over 600 viewers over the last 3 days, and that number continues to grow as people continue to view the recorded sessions on our YouTube channel. We heard presentations on a variety of scientific topics, including plants, wetlands, water quality, mollusks, fish, birds, bats, river otters, invasive species, population dynamics, toxicology, DNA analysis, antibiotics, forensic investigations, impacts of pollution, animal behaviors, geology, economics, and the challenges of formal and non-formal education during this pandemic. Thank you to all our presenters. It was a pleasure to host a symposium that represents so many areas of science. Okay, and now on to the presentation of the Dr. Jerry Covert Student Awards. Dr. Covert was the original executive director of the Regional Science Consortium and really laid the groundwork of what this organization is. He initiated the membership of the RSC to include colleges and universities, state and federal agencies, school districts, and other nonprofits with similar missions. Dr. Covert believed collaboration between faculty at different institutions was invaluable. Dr. Covert has a great value for scientific research. Many of the research projects he initiated included the water sampling for bacterial concentration on our swimming beaches, the BASE study, and the buoy program, which are still ongoing today. Dr. Covert also believed strongly in the student research and the opportunity for students to participate in research, and equally as important, the opportunity for students to present their research at conferences such as this symposium. As elected by the RSC Executive Committee, it is my pleasure to announce the Dr. Jerry Covert Student Research Awards presented to students demonstrating excellence in scientific research and presentation. This acknowledgement is in the recognition of Dr. Covert's commitment to the Regional Science Consortium and the scientific research in this region. I am grateful for all he has contributed to make the RSC a great success where it is today. And serving as my mentor over the years, I'm very appreciative. Thank you, and I will be delivering this plaque to you shortly. I will now present the student awards. We will start with the poster presentations. The first overall in undergraduate presentations for a poster is Daniel Kaufman and Simone Taylor from Gannon University, presenting on microplastics, atmospheric deposition, and transport. And we have Daniel and Simone with us on our Zoom.
Hello, Jeanette. Thank you very much for this award. I guess I would probably like to thank Dr. Homan and my partner Sim for helping us out with this great project and doing such a great job in finalizing the proposal for some of the research that we want to do. But I also think that a big thanks needs to go out to everyone at the Tom Ridge Environmental Center for, you know, in the Regional Science Consortium for allowing us to present, for doing this every year, and you know, making sure that this took place in 2020 under such difficult conditions. So yeah, thank you very much, and we appreciate it.
Thank you. It was great for you to join us. Our next presentation is the first overall in graduate poster presentations, goes to Arjun Malhotra from LECOM, and they presented on the developmental trajectory of the auditory brainstem response of valproic acid-induced rat model of autism. Arjun?
Hi, thank you so much. It's such an honor to receive this award. Huge thanks to my research advisor, Dr. Koleza, for his support, especially when COVID made collecting data so difficult. Thank you to the RSC for hosting this event and allowing us researchers to showcase our hard work. It's been such a pleasure. Thank you so much.
You're very welcome. Congratulations. We will now move on to the oral awards. For the second place overall in undergraduate oral presentations, the winner is Pooja Mehta from Penn State Behrend, and the presentation was Selection Preference in Hylela Azteca Development of a Behavioral Assay for Ecotoxicology. Congratulations, Pooja.
Thank you. I would like to say thank you to my research advisor, Dr. Samuel Newtile, for allowing me to do research with him. Thank you to Dr. Beatty, Dr. Simpson, and Kyle as well for helping on this project. And lastly, thank you to the Regional Science Consortium for allowing me to present this research.
Congratulations. Our next presentation is the first overall in undergraduate oral presentations. And the award goes to Sage Grenz from Penn State Behrend, investigating the role of invasive species in the introduction of heavy metal toxicants. Sage?
Hello. So I would just like to thank you guys actually for giving me an opportunity to present my research in a way that's not boring my poor family members and friends. They always hear me talking about the snails and they're like, Sage, no one cares. Like, come on now. But anyhow, I'd also like to thank Dr. Newtile, my research advisor, for allowing me to work on the project and helping me out every step of the way. Also, Dr. Simpson and Dr. Beatty for helping out with the project and going out and collecting samples when I couldn't. And like I mentioned in my presentation, some of my classmates and friends, my friends Matt, Austin, and Cassidy for collecting snails the previous summer so I could start to validate my methods last year.
Congratulations. Thank you. All right, we will move on to the second overall in graduate oral presentations. And the award goes to Emily Brooks and Teresa Decree from Mercyhurst University on their study of a geomorphometric study on sex estimation of the pelvis on skeletal remains, a pilot study. And they could not be with us this afternoon, but congratulations and thank you. And finally, our first overall in graduate oral presentations is award to Allison Burkell from LECOM, and her study included the investigation of a long-range glycemic projection from brainstem interneurons to the thalamus. And Allison could not be with us this afternoon either, but congratulations. And congratulations to everybody that presented. The presentations this year were impressive, and I know the judges had their work cut out for them. Every year we're so impressed with the caliber and quality of the research. It really is, it's great to sit back and listen to everything that people are working on. To wrap things up, I would like to thank the RSC staff, Jen, Amber, Sean, and Sarah, for their hard work in preparing this event. It was a whole new way to approach the symposium, and it was a different experience for all of us. But the one thing that we joke about is we didn't have to worry about cheese pizza this year. I'd also like to thank the RSC board members that were part of the planning committee to transition this from an in-person to a virtual event. I'd like to thank our sponsors that realize the value of the symposium and continue to support us year after year. I'd like to thank WQLN Public Media for sharing this event with their viewers. And finally, I'd like to thank ETD Photography and Video that made this event possible through multiple levels of media support and live streaming from where we are here at Radius Cowork at the Renaissance Center in downtown Erie to you at your home or your office or wherever you're working from nowadays. So as we close this symposium, another year in the books, we look forward to seeing you, however that may be next year, maybe in person, maybe virtually, or honestly, maybe a hybrid of both. Our next symposium is November 3rd through 5th, 2021. Please mark your calendars now. The 17th, it'll be our 17th annual research symposium. It's hard to believe we've already got through 16 years. I thank everyone for your participation and your support, and have a wonderful weekend.